I think we can start on schedule. Carabellese, da ora in poi possiamo condividere la diretta streaming.
Sì, professore, ero già, diciamo, perfetto. Siamo partiti anche su YouTube. Io adesso mi disattivo e ovviamente rimango, diciamo, in remoto nascosto. Se avete bisogno sono qui. Grazie,
Okay.
buona giornata, a dopo.
Grazie. Allora, signori, shall we start? Okay? Eminent academic authorities, distinguished speakers, representatives of European companies, universities, student association of industrial engineering and management, dear participants attending the conference from all corners of Europe, ladies and gentlemen, I'm very pleased to welcome you all to the first virtual European conference on higher education, industrial engineering and management in the light of Industry 4.0 paradigm, state of the art and perspective. The conference aims at contributing to the ongoing transformation of the higher education in Europe in the area of industrial engineering and management. Industry 4.0 is fostering irreversible changes due to digitalization and ICT connection of everything, ranging from production systems, infrastructures, services, up to activities of our everyday life. The pervading nature of the transformation requires renewal and interaction of and among all engineering disciplines. To this concern, the event goes beyond industrial engineering and management. It's an honor for me now introducing the academic authorities. Professor Francesco Cupertino, Rector of the Polytechnic University of Bari, and Professor Giuseppe Carbone, Head of the Department of Mechanics, Mathematics and Management of this university. The floor to Professor Francesco Cupertino.
Thank you, Gianni, and good morning again to everyone. First of all, I would like to thank you, all of you, for participating in this event. Unfortunately, this is another virtual welcome at Polytechnico di Bari. Still hoping to welcome you soon in person in Bari. I would like also to thank all of the colleagues coming from both academia and the industry who gave their contribution to this relevant project. The way out from the pandemic needs new ways of interaction between higher education system on one side and industry players on the other side. We need more interaction in designing the courses, in particular in industrial engineering and management. That is a field where there is a strong need for young talents that should leave the universities with a training much closer to the needs of industry. I gave a look at the program of this event today. I also have seen that there will be a focus on the digital tools for training in academia. This is another topic on which we have to share ideas and to share plans, because with the pandemic we instantaneously switched to digital training. Now we have to take the best of digital in training and of traditional way of doing training in person, and to think about something new that will give to us many new opportunities to link together the training university courses and the working life of our students. And then at the end of this my short speech, I would like to thank all of the speakers that will participate today to this event. And again, I hope to see you soon in person in Bari. Thank you again, Gianni.
Thank you, Francesco. Thank you, Director. The floor to Professor Giuseppe Carbone, Head of the Department of Mechanics, Mathematics and Management of this university.
Good morning to everyone. So I'm very pleased to be here to thank you for being here. I thank you all the professors, the people from academia, and I'm happy that this event is hosted by the Department of Mechanics, Mathematics and Management, because this department is a department of excellence in Italy, one of the 140 about excellent department in Italy, and one of its aim is actually to improve and to gain excellence in also in teaching, in research, and other topic. But now it's very important to have excellence in teaching. So I'm very happy to be here. And as also the rector has said, it's important to investigate new tools for spreading teaching and knowledge all over the world. And one of the tools is related to digitalization. And indeed, we have discovered in the last year and a half that these instruments and these tools can be very, very important to help people to spread knowledge, to help teachers to provide lessons to their students. And these digital tools may even be useful to replace, not always, but in some circumstances, labs, experimental labs. So it is very important to look at these new tools, this new way of providing lessons, of delivering knowledge that has to be actually has to go parallel to the in-presence teaching. So that's really important, and I'm very happy to wait for the result of this conference today. I will be in contact with Gianni and ask him to inform me about the new developments in this field. This may be very useful for us also to try to attempt new way to provide teaching and to spread knowledge also among our students. So thank you very much, and I wish you a very good work today. Thank you.
Thank you very much, Giuseppe. Thank you very much, Professor Cupertino, Professor Carbone. Your presence today witnesses the attention paid by academia and by our university to the challenges the higher education system is facing with. The topics you raised will be a matter of discussion in the very next weeks. We will be involved in the writing of the new higher education transformation agenda as coordinator of Erasmus Plus project, and we will have the first meeting on next June the 3rd. So this conference will bring to me ideas and inputs for contributing in writing the agenda. Thank you again for your presence. Now, according to the program, let me provide you with a short introduction of the conference. It consists of two main parts. In the first one, a needed gap analysis on higher education, industrial engineering and management in the view of the Industry 4.0 will be the main theme of the presentations. A deep and extended survey has been carried out as an activity of the Industrial Engineering and Management Erasmus Plus European project. In short, the IE3 project that I have the privilege to coordinate. Viewpoints by academia, companies, and students will be presented and discussed. In the second session, after the coffee break, outstanding speakers in representation of all stakeholders will contribute to a SWOT analysis so as to identify strengths, weaknesses, opportunity, and traits in the renewal process of higher education. My sincere gratitude to all invited speakers and panelists for accepting our invitation. During this session, attendees will be enabled and encouraged to put questions to the Zoom and YouTube conference chat, as the event is also streamed on the YouTube channel of the Polytechnic University of Bari. Questions will be grouped by similarity and will be answered in the final question-answer time. Let me provide you with rationale and context of this conference. The rationale that makes the event of great significance relies in the challenges the European higher education system and industrial sectors are jointly facing with in the green and digital transition, as well as with the global competition for human capital. 10 years after the Zukunft project Industry 4.0 firstly appeared in Germany in 1211, the new production paradigm shows criticalities in its implementation. A major criticality relies in a technological paradox that sees technological investments in production assets increasing at a faster rate than the increasing rate of knowledge transfer and human capital education. About 94 million workers may not need to change occupation, but will especially need retraining, and 21 million may need to change occupation by 2030. Furthermore, in the next decade, workforce aging is expected to reduce the size of Europe's labor force by around 13.5 million. A quantitative and qualitative gap of knowledge workers is a threat for European companies in the global competition for human capital. A critical mass of knowledge workers is now required. But what's the context and the role of higher education institutions? As we will see in the next presentation, on the average across Europe, academic, industrial engineering and management programs do not completely meet industry needs. And the European higher education institutions show, on the average, of course, an inertia in updating business-driven program in the light of Industry 4.0. Knowledge gap is increasing across Europe, also due to structural constraints, legislative constraints, as well as not coordinated efforts among European universities, and finally, insufficient university-industry interactions are identified as major causes of a mismatch between higher education offer and industry knowledge needs. A systemic innovation process and new incentives jointly involving university and companies are now required. What's the future of a higher education institution? Favorable condition to foster the innovation process is now offered by the long-range European knowledge strategy. The knowledge strategy of the European Commission states the need to reform the mission of higher education institutions that should be finalized to serve and tackle challenges of a modern society. Reforms of higher education and research areas have to be pursued under a holistic approach, as both dimensions, higher education and research, are required to serve the society, according to Action 11 of the European Knowledge Strategy. The European University Initiative and Research piloted under the Erasmus program and supported in its R&D dimension by Horizon 2020 will help the transformation process, offering a long-term framework for transnational cooperation between universities, allowing for stronger borderless cooperation and circulation of knowledge and talents. To address the strategy outlined by the European Commission, a higher education agenda is under construction, and we all today have the opportunity to contribute to it. Let's have a look now to the future. While pandemic is causing social and economic damages never seen before since the end of the Second World War, it also represents the opportunity for accelerating the innovation process of higher education and knowledge transfer, starting with the ongoing digital transformation of societies. Systematic and synergic interaction between European universities and business sector will be pursued while preserving the autonomy and peculiarities of each stakeholder. The 2021-2027 multi-annual financial framework and the recovery instrument Next Generation EU are unprecedented efforts of EU towards a modern and sustainable Europe, taking care of values of inclusiveness and subsidiarity in favor of less advantaged areas and social classes. Context and vision of the future are premises and rationale of this first European conference on higher education, industrial engineering and management that has been organized as a milestone in the Erasmus Plus project, Industrial Engineering and Management Higher Education, in short, the IE3 project. Let me provide you with a very short introduction of the IE3 project. Its overall aim is in line with the Knowledge European strategy, as it aims to contribute to innovate European higher education, industrial engineering and management in a close university-industry partnership. The project has been funded by the Knowledge Alliance Action of the Erasmus Plus program with around 850 kilo euros over 3 years. I like mentioning the project ranked at the top 10% of the Knowledge Alliance project across Europe. The consortium of the Erasmus Plus project consists of 4 academic partners: Linköping University, Universidad Politécnica de Madrid, Poznan University of Technology, and the Polytechnic University of Bari, which is also the lead partner of the project. Companies' project partners are Bosch Tecnologie Diesel from Italy, Arruti Catenaria from Spain, Alcomot from Poland, and Implema from Sweden. The consortium also includes 2 technical partners, Valuedo and Infotech, for project management and dissemination activity. Associated partners are the European Academy for Industrial Management in representation of university professors, the European Students in Industrial Engineering and Management, STEAM, in representation of students, and for companies, Madrid Network for Spain, and IE3 Oxygen, a company's research center from Italy. The roadmap of the project develops along 6 milestones. By the first 2 milestones, a European survey led us to a deep and extended need gap analysis, as well as to the conception and definition of a body of knowledge of industrial engineering and management to support the renewal of programs across Europe in the light of Industry 4.0. 1 year and a half since the project kickoff, this is the current project progress. Next presentation will be focusing on the current project achievements. Future activities will see us engaged in the renewal and digitalization of master science courses, as well as to a renewed industrial engineering and management master program with new syllabi, digital education tools, e-learning course modules, and transfer methodology. Activities will be carried out in close university-industry partnership according to the spirit of Knowledge Alliance action. That's all, friend. And thank you all for your attention and for being here. In the next presentation, the current IE3 project achievement will be presented. Now it's the time for the next presentation. The floor to Professor Di Gesi and then to Professor Mossa of the Polytechnic University of Bari. Thank you very much for your attention.
Okay. Thank you, Professor Mummolo. I share my screen. Okay. Welcome to everybody. In this first part of the conference, I will give you some insights on the need and the gap analysis performed during the IE3 project. The aim of this research was to focus on the competencies and skills mainly required by companies in the knowledge area of industrial engineering and management, as well as to compare this demand of knowledge expressed by companies with the offer of higher educational institutions in Europe. In order to do this, a survey was designed and designed and carried out. The survey started with qualitative interviews with companies, and the results obtained were adopted for designing a quantitative survey addressed to all the stakeholders in the area of industrial engineering and management, that is, companies, academics, alumni, and also students. The answers received from both qualitative and quantitative survey have been elaborated in order to perform the need and gap analysis. In the next slides, I will show you some main results of this analysis. Let's start with the qualitative survey. The survey encompasses semi-structured interviews with companies, and the main aim was to discuss with companies on professional roles, educational levels, and personal attitudes mainly required by companies. At the same time, main knowledge areas of interest have been investigated. As you can see in this slide, 30 companies located in the 4 project partners countries have been involved in this first part of the survey. Companies were mainly large companies working in the manufacturing by parts sector. Results obtained from the first part of the survey are in this picture. As far as concerns professional roles, companies are looking for new and multidisciplinary competencies in order to be able to react to rapid market changes and remain successfully. For all professional roles considered, Master of Science is the most frequent educational level required. Finally, all companies involved in the survey stressed out the key role of the soft skills, considered as important as, and sometimes more important than technical or hard skills. In the second part of the survey, 4 questionnaires have been designed and coded in Microsoft form feedback from the 4 stakeholders identified, so companies, academics, alumni, and students. The questionnaires have been designed on the basis of the results obtained from the qualitative part of the survey, as well as on an extensive literature review aiming at identifying the knowledge resources within Industry 4.0 field. At the same time, the output obtained from the content analysis of more than 350 syllabi collected from industrial engineering management master level programs offered in 16 countries have been adopted for designing the questionnaires. In the questionnaires, the knowledge areas investigated were clustered into 2 sub-areas: learning skill and competencies and learning environments. In the first sub-area, knowledge and competencies, as well as operational tools required by companies, have been investigated. In the second sub-area, both knowledge transfer methodologies and learning activities have been investigated. In each of the 4 questionnaires, the respondent was asked to rate both the offer and the demand of each item in the 2 sub-areas. In order to do this, predefined answers were made available, designed according to a Likert evaluation scale. In the period May-June 2020, more than 700 answers have been received from more than 20 countries. As you can see in this slide, 75 companies and more than 100 professors from 64 universities were involved in the quantitative survey. At the same time, more than 500 answers were received from students and alumni. One of the first important results obtained from the questionnaires concerns the demand of knowledge expressed by companies. In all of the area investigated, the company's demand of knowledge is greater than their internal offer of knowledge. This result is independent from the size of the company. At the same time, however, it is more evident in case of small, medium enterprises characterized by very low offer of knowledge. When the demand of knowledge expressed by companies was compared with the offer of higher educational institutions, some priority areas were identified. In these areas, there are the main gaps between the demand expressed by companies and the offer, the actual offer of higher educational institutions. In the knowledge, skills, and competencies area investigated, gaps were identified in both soft skills and technical or hard skills. In descending order of importance. Among soft skills, the ones characterized by the higher gap values are problem solving and decision making, team working, and communication skills. The gap between the demand and the offer of soft skills of students and alumni, considering soft skill as the main shortcoming in the Master of Science programs attended. As far as concerns hard skills, the one characterized by the high gap values are project management, strategic management, and safety of work. In the operational tools area, analytical competencies show the higher gap values. The highest gap values were obtained for management software tools, computer-based statistic competencies, and big data analysis. The analysis of answers received in the knowledge transfer methodologies area investigated gave as main result a general preference of face-to-face methodology, which is still the most required transfer methodology. As far as concerns web-based learning sessions, asynchronous modality is preferred to synchronous ones. Another very interesting result obtained from the survey relates the involvement of companies in the learning process. More than 50% of answers received pointed out the need of more courses held by industry professors and longer period of industrial internship. This direct involvement of companies in the training process is the base of the knowledge alliance between industry and academia. Concluding, the need gap analysis carried out in the IE3 project highlighted the gap between the demand of knowledge expressed by companies and the offer of higher educational institutions. Major gaps are in soft skills that companies consider of highest importance. The need gap analysis allowed to identify some priority areas that have to drive the redesign of Master of Science programs in industrial engineering and management. Finally, the analysis stressed out the key role of a knowledge alliance between industry and academia in industrial engineering and management. Now I leave the floor to my colleague, Professor Giorgio Mossa, who will give us a speech on the body of knowledge defined in the IE3 project. Please, Giorgio.
Okay, thank you, Salvatore. I think you can hear me properly. Dear colleagues and dear participants, first of all, I want to thank Professor Di Gesi for his speech and his kind presentation. And given the short time at my disposal, I would like to quickly describe the main elements related to the body of knowledge for higher education, industrial engineering and management as conceived and drafted in the framework of the European project Erasmus+ IE3. In our vision, from our project, the body of knowledge represents a conceptual scheme and a set of technical guidelines, both for the design of new courses and for redesign and improvement of existing courses and master programs in industrial engineering and management, according to the indication of the needs that emerged from the gap analysis conducted at EU level, as Professor Di Gesi told us a few minutes ago. The body of knowledge is a complex document that has been available on project website at the link provided here on the screen since January 2021 for all colleagues and all the stakeholders. In our perspective, your comments and suggestions from all of you in order to improve the document will be truly appreciated and can be made both directly on the website or via social media channels like LinkedIn and Facebook. And they are really easy to use and for your comments. The body of knowledge consists of 4 distinct parts, each guiding a specific aspect of the design of higher education, industrial engineering and management. The first is goal and scope. Then we have built up standards for course renewal. We have guidelines and use cases, at the end a summary of the most relevant project outcomes. So you can read it through the document and found the specific part you need to improve your courses. In first part, we have an introductory part that clarifies that the objective is to make available the results of the project by disseminating the IE3 project outcomes across Europe, but at the same time, the body of knowledge could be the foundation upon which higher education institutions through Europe can develop their own strategies, policies, procedures, and tools for renewing courses and programs in a dynamic environment. So in the first part, that is part A, the body of knowledge provides the higher education institution with the standards for course and programs renewal in a formal and structured process according to the international best practices for design and management of complex projects and systems. The general conceptual framework is based on the continuous improvement approach of a quality system for higher education institution. The approach obviously is process-oriented and built up upon multiple iteration of the so-called PDCA, Plan, Do, Check, Act cycle, also known as Deming cycle. The 5 main processes of the cycle are initiating, planning, executing, and then monitoring, controlling, and continuous improvement. The initiating process aims to identify the stakeholders, first of all, relevant to the course or program renewal processes, the needs and requirements of these stakeholders, and the consequent strategic goals. In our vision, this is one of the most relevant phases in whole process, together with the planning stage, where the focus is to identify the compliance obligation relating to the specific national laws and regulations. This is a very crucial point. And as well as the rules or guidelines from regulatory agencies at European level, IDES, ENQA, that is the European Association for Quality Assurance in Higher Education. Then to assess how compliance requirements apply to the design, implementation, maintenance, and continuous improvement of new courses and programs. Moreover, we need to establish objectives for the renewal of courses by considering knowledge requirement as derived from one side from demand versus offer gap analysis, and on the other side from compliance obligation. Knowledge requirement, as we heard a few minutes ago, pertain both hard and soft skill. We have to always to remember this. With this regard, at the end, we need to implement an effective performance evaluation systems to make possible the continuous improvement of monitoring and the continuous improvement of the system. Then we have the executing phase, whose main output are course design and validation and course resource and operations. This is a stage where stakeholder engagement and public dissemination take place. In our vision, managing stakeholder engagement is the crucial process of communicating and working with stakeholders, especially with industrial stakeholders, focusing on their needs and expectations, and hopefully fostering their active involvement in the process. Finally, we must plan, design, and implement monitoring and controlling through performance evaluation, audit, and review, and the corrective action under the continuous improvement goal. In part B, in this section, the body of knowledge provides guidelines for the planning phase of the course renewal process. Moreover, use case and example from the IT project are organized in 4 main steps. The first 2 are analysis of the educational offer in the knowledge areas identified and analysis of the training needs of stakeholders. Then we have to perform an evaluation of knowledge gaps. Details on 3 phases were fully provided before by Professor De Gesis. And finally, we can define the so-called competence matrix. This is tools upon which we, in the project, we build up some guidelines for competence matrix, and these possible guidelines are the granularity of knowledge, skill, and competence, KSC. It founds upon the pillar of decomposition of general KSC topics into more specific subjects, the so-called knowledge pills. Then we have to guarantee the flexibility of KSC, of knowledge, skill, and competence. And it allows the subject's assignment, even based on nature and availability of resources. Finally, the rolling approach is a must, and that dynamically fits contingencies emerging from the gap analysis in a constantly evolving environment. At the end, part C of the body of knowledge provides a summary of KSC, knowledge, skill, and competence, and in this case, educational tools derived from the quantitative analysis of the survey. 2 main clusters of hard and soft skills were identified and classified. Besides, 2 main clusters of learning environment were also identified. Knowledge transfer methodology on one side and learning activities on the other. Unfortunately, my time is now over, and so I leave the floor to the next 2 distinguished speakers on these very interesting topics. They will be Professor Joanna Olesko-Slapka from Poznan University of Technology and Professor Joaquín Orgueres from Universidad Politécnica de Madrid in Spain. Thank you for your kind attention, and please remember we are waiting for your comments on the body of knowledge, and you are very welcome. Please, Professor Orgueres, you're welcome.
Thank you very much, Professor Mosa. I hope you can hear me properly now, and also Perfect. You can see the presentation. So thank you to all the previous speakers and participants in the conference for having me here. Joanna and me, we will try to address some comments and proposals regarding the teaching and learning digital tools for higher education in industrial engineering and management. Then I will ask you to visit the URL I share into the chat, because we want to collect your feeling about some questions, relevant questions to adapt a little bit the presentation. So thanks for visiting the place. Then you can use it by mobile phone or whatever. So the first question can be seen right now. So it's about, sorry for asking your somehow your age, but it's relevant to understand some elements into the understanding and the feeling. So that would be great to please participate into the query, into the survey. I really appreciate your input. So it's just a matter of checking. Yes, thank you. So as expected, boomers and Gen X are probably the big part of the audience. Okay, someone else. Okay. Okay, so please visit let's ask the Gen Z to push forward into the competition. Thanks. Okay, thank you. Well, yes, as expected. Okay, as expected, the younger generations are the winners. Okay, thank you. Thanks. Next question is which kind of engagement or which kind of role are you comfortable to be described? So if you are a student or oops, I think I missed some stop here. Yes. Then please try to tell us about your activities, about professionalism or academic behavior, etc.
Professor Joaquin,
yeah.
the ballot is closed at the moment. We cannot perform the ballot.
Oh, sorry. Let me check. It's closed.
Yes.
Oh yes. Yeah, I think you can now
yes.
vote.
Now it works.
Okay, thank you.
Thank you.
Okay. Well, more or less academic people. That's fine. Also, students are a relevant part of the game. And then finally, for this part is, what do you think about the higher education model as it is right now? So do you believe it fits the expectations you have? Something is needed to be improved? So any input you can provide us with should be really appreciated. Okay, good for boomers. That's fine. Okay, I think the feeling is more or less clear. As in accordance with what we learned from the previous presenters, panelists. So I think some changes are needed. Then let me move quickly into the main part of the presentation, which is try to provide context to why to use new tools, which kind of topics need to be addressed, need to be engaged with to be successful in that kind of transformation we all recognize as needed. So the first thing is I want to highlight some facts. First one is how society is moving. Professor Momolo told us before that there is a lack of parallelism in the development between the transformation of production systems and the transfer knowledge, and also particular aspects of the new learners, no matter only for students in the classical courses, but also for people needing retraining as Professor Mumuro presented in his view. And then also how what are the needs we need to address to be successful in that engagement. So first point I want to highlight is how the society is getting transformed. Just looking into how we change as a society the way of manufacturing goods. So from rigid and manual processes in more agile and automatic approaches, production moving from standardization to personalizing goods, and supply chains based on classical stock approach, much more into dynamic and predictive demand. And so a lot of slightly, probably not for all the people clear changes, but dramatic changes in terms of how we address and we perceive the needs and how we want to react to those demands. Just having a look into the classical decision-making systems, we can see on the left part of the slide the classical one, like blackboard, charts, panels, different element of communication. Into the right part of the screen of the slide, when you can see workplaces where digital tools are placed, helping workers, but also learning from them, measuring them, and also providing convenient feedback as they need to perform better and improve and realize what kind of needs they need. So they are requesting. So you can see here in the lower part of the slide, and the lower right lower part of the slide, a worker having some projected areas of information, helping her to move according to the mounting station she's operating. Just from Zoom, we can see from the statistics, as Professor Momolo told us before, how the demand. This is the figures are for the first for the global view, and then the 20,000 shortfall is for the UK. So you can imagine the amount of demand of new educated engineers we are facing in the coming years, and also the bias we are experiencing because most of the current workforce is white and male. So there is a lack of diversity we need to address as well, but also not forgetting the critical trends we need to care about, like sustainability, circular economy, innovation, entrepreneurship, etc. So there are all things that we need to integrate into the transformation of the education. Then what people start to implement nowadays in the factories is that kind of integration between new ways of making decisions and getting focused quickly into the problematic areas. So you can see here one shop floor where some kind of virtual reality or augmented reality is presented, showing the performance of the individual cells of manufacturing, and then keeping the attention on which part is needed, making possible for the operator to be aware and to quickly address the demand. So these are the things our engineers or new educated engineers need to manage properly and to be able to implement, to deploy, to stand, and to handle, to make sure that all the resources are able to do their best in the production or in the design or in the conceptualization, etc. So this was for the society changes we are understanding. Then let's see how the new requirements from the people attending the education. I told you again, indeed, students at the university courses, but also people coming from the industry looking for retraining experience. So they are mostly digital natives, in different way than before, much more social in a different way than before, but also much more social. And then, which is a key point, they are less focused. So as far as they are exposed to very high level of, let's say, motivation, so they are distracted very quickly. Then to keep attention, they need to be deliberate and to be fed with relevant information and quickly, very quickly. This very common, get those students seeing videos, for instance, at 2x or 3x of the normal presentation because they need to go quickly, what's next. And they are also concerned about the practical skills, as already mentioned, as you said before. Okay, there is kind of mostly theoretical education leading the game. So we need to transform also the way we understand the education schema. And then next point is not only because of the student, but also the topics we need to address. Most of the, as presented in the left part of the slide, most of the things we need to talk about to provide that kind of transformation, like contextual intelligence, emotional intelligence, strategic intelligence. Most of those were out a few years ago from the curricula of the engineers. So we need to pay special attention, as Professor Di Jessi and Mosa told us before, about the soft skills and integrated way, in a way that we need to transform not only the environment in terms of digitalization, but also pay attention to those kind of drivers. Otherwise, there is no future in the transformation. Then another relevant point is pay attention to the transformation of the way of learning. So normally we design in the millennial era, we make some digital tools available, but replicating the process as we teach from many years ago, from the classic, the Greeks culture. So the centering into the teacher. So We learn now that the newcomers into the engineering role learn in two different paths. One is personal learning, which need to be, as Professor Di Jesse told us from the survey, asynchronous, mainly asynchronous. So, and also getting social as far as is mandatory from the requirement from the for the student in some kind of social learning in collaborating to address the point. So we need to transform the courses in also that direction as well, providing social tools able to learn from, and also asynchronous personal learning as well. And this is not only valid for university attendant students, but also for people needing retraining, because in the end, there is classical statistics showing how dramatic is the amount of money invested in training and retraining, and the easy way to lose the focus and to lose the what was learned before. So then we need to focus in looking for the tools in specific keywords or paradigms, like, for instance, because of the generation attributes, microlearning, showing small concepts in quick and diverse media, easy available at any time and anywhere for the interested people, promoting asynchronous learning, but also gamification tools helping the participant to interact and to have social understanding, and also competition. And then for sure some other requirements which are needed, like infrastructure new demands for big analytics, etc., which also require funding as usual. But these are critical paradigms we need to care. In addition to the adding part of the teacher and facilitators, we need to configure the course according to the topics they want to emphasize or to address. Then going forward into finalizing the presentation, then we need to emphasize also some barriers and risks, mainly related to resources. So people in charge of producing that transformation, for sure, lack of proper capabilities or skills, and for sure, as I already said, so money, investment, and also indeed data security is always, because as we are going to be more digital, we need to pay attention to keep at safe also the proper access, backdoors, etc., making possible to provide safety for the users. So there is kind of studies already mentioning the critical point we need to be aware of in order to design successful approach. All in all, one point I want to stress specifically is that nothing is possible except very interesting initiatives, but nothing in terms of transformation is possible if we lack a strategy. So we need to provide, is one part of the learning process, and this is because we provide the body of knowledge for transforming courses, because we need to have a strategy. What is the future one? Where we want to go to? And then how to make that transformation possible. It's not a matter of making a revolution. It's a matter of making a continuous transformation with clear guiding. So we need to pay attention to what's next, and we also need to find the way to make the internal transformation of the whole system. And this is the critical point. It's not a matter of one course, but it's a matter of programs as well. It's a matter of everything around the education at once. So this is the critical point for understanding the body of knowledge need. And then finally, I want to ask you to see, after my short presentation, if I was able to convince you of some of those values. Then please try to try to share with your thoughts about what you think about the higher education system. I think it's open now. Yes, it's open now. Okay, let me change into the outcomes. Okay, yes, I think I also agree with most of you. There is different paths. There is no symmetric behavior in different universities. This is because education, research in the field and to develop some best practice is mandatory, as we need to align in the, at least in the European Union area, the transformation of the things. Otherwise, we will get some clusters, which probably is not what we want to have in terms of universality of the education. So just going to the conclusions from my side, thank you for your participation first. And then, so yes, we think we not only need to renovate courses, but also to have a continuous analysis and clear defined strategy, trying to address and to understand what is needed from society, and also taking into account the participants, which are learners and also teachers for sure, and then trying to provide as much flexibility as possible regarding tools, regarding time for and place for learning, etc. So that's all from my side. Then I will grant the floor to Professor Joanna Oleskova from Poznan Technical University for continuing the same strand. Joanna, the floor is yours.
Okay, good morning everybody. I try to share my screen. Is my presentation visible?
Yes, it is.
Okay. I'd like to continue the topic which Joachim presented us about teaching and learning digital tools. My presentation will be related to rather to technical perspective and tools. What kind of software, what kind of tools universities can take advantage to improve the level of education and also involve students in teaching learning phase to provide them adequate skills to become later like engineers for zero in companies. Joachim provided us introduction about challenges, what kind of characteristic we can relate to future engineers, like people, like humans, but from the perspective of teaching, there is also lack of adequate skills for teachers because they are not trained enough to utilize sophisticated software, digital tools. On the other hand, even if technology is available, we do not have people who could implement this in our universities. We will find a lot of papers about that, how to deal with digital technologies, how to improve digital skills of students as well as teachers. One perspective focus that such technology, ICT system, they for sure facilitate development of skills and abilities of our students and future engineers. And they will become better employee in the future. There are 3 dimensions when we want to develop our teaching system for future engineers. The most important is of course technical content, but at the same time we should remember and keep in mind soft skills and teaching paradigms. All of these components have to be combined in one teaching program for our students. And if we want to develop a new education system which enables our students to become engineers, we should combine all of this aspect in our new education system. When we look at these components as technical and so on, from technical perspective, we should focus, for example, on communication network, embedded programming, artificial intelligence, computer security, and all other aspects which are components of Industry 4.0. And they should be combined in meaningful program for our students. And at the same time, our expectation is to provide for our students practical experience with all of these fields. And this is the very challenging objective for universities, because they have to rethink, they have to redesign education system, and there should be a huge relationship between education and practice. And therefore, the scaffold knowledge creation is vital for universities. When you look at the tools, what kind of digital learning tools can be applied for our students, we will find a lot of different methodologies, we can say. Like we can use virtual reality, augmented reality, some badging, gamification system, blended learning. Some of them are more common and used very often by universities, especially now in pandemic situation. I think there is no university without e-learning system, but some of them are used rather rarely because they require more sophisticated software IT system, and not each university can afford to use such digital tools in their learning teaching practice. I'd like to present on next slide some sample digital tools which can be applied by universities to improve the teaching system of students. One of them is, for example, the group of digital dashboards. They allow to monitor the progress of students in learning environment. Such digital dashboard is, for example, assessment system. This system allows teachers to create materials, and this one is dedicated to mathematics, but we will find also different ones which refers to different courses for engineers. And students can perform this task, interact with researchers, and therefore furthermore improve their level of knowledge in this topic. When we look at distance learning, of course, we can use simply webinars, blended learning, or asynchronous learning. The number of available systems is also quite wide. I show on next slide what kind of technologies you can use. If we want to, this slide is taken from one paper about comparison of different technologies which I applied in digital technologies in higher universities, which teach engineers, and we can use we can rely on big data, RFID system, Internet of Things, mobile services, artificial intelligence, cloud computing, and so on. But so far we already know, and it was a little bit presented by Professor Mossa and Digiesi, that current curricula at universities not always combine all of these aspects, and some aspects are omitted, and students do not have adequate knowledge, skills about these components. At least maybe they have theoretical background, but they are lacking of practical knowledge how to deal with Internet of Things, for example. The list of learning methods is also very long for engineers. We can use some animated simulations, and they are very common to deal with warehousing, logistic, production system, and so on. There are also some web portals, diagnostic system for building construction, CAD/CAM system which are interactive, or living system to teach some engineering concepts. At the same time, mobile learning in web-based instruction or virtual engineering education. The big advantage of such methods is to involve students in some practical case studies, and also enable them to test, to analyze real-world scenarios, and to simulate what can happen if they introduce some amendments, some modification to the system, and they can optimize real production, real system, which furthermore can be the background of their work like engineers. Currently, the technologies are ready, so it's not problem to find to start using particular technology also by universities. Of course, there are some problems, for example, with money and budget for such teaching environment for students. But the main challenge is how to create the content and at the same access to technology, and later to create it and distribute between students, teachers, and so on. Such platforms, such learning platform, this is variety of digital interactions between students and teachers. And of course, there are some universities which are quite well developed in this field, but a lot of universities still need to improve digital technologies for students. There is one article, one research about top 100 tools for personalized learning and for working environment. And this list is not very sophisticated, and I think each of us know all of these tools. And according to this research, if we look at personalized learning, YouTube is on the first position, then we have Twitter, Zoom, and so on. From the workplace learning perspective, Zoom is on the first position, then Microsoft Teams, and then we have quite simple tools also like PowerPoint, WhatsApp, and so on. Some of them are connected strictly with didactics and formal learning. Some of them refers to learning from working. Some we have here some system for productivity, but also simple file sharing and so on. But we do not see on this list very advanced system. So on the one hand, maybe the we do not have access to such system, or we do not have adequate skills to use them in practice. There is also a different division of system which we can use in educational environments. Some of them are called like learning innovations, and also computational tools in the engineering practice. I'd like to provide some information about sample system, like one of them, which is in group of learning innovation. This is CATME system, and this is system dedicated for team working. And in each company, we need to we require from our employees to be able to work in teams. It can be different type of teams, and this CATME system combines different components like peer evaluation, rate practice, team maker, but it's dedicated to its online tools for teach students how to work in teams. Another software, Concept Warehouse, AICHE Concept Warehouse. This is web-based tool, mainly dedicated to chemical engineers. It has different components like concept test, concept inventories, instructional tools, and the main idea is to provide students some simulation scenarios to analyze chemical processes, but also they have some courses included, interactive virtual laboratories and so on, to work under real scenarios, we can say. Epistemic games, this is another digital tools which is quite useful for our students. They can become a part of real world problems, case studies, and they can involve in solving such problems. We can find a lot of different epistemic games. I put here only 3 types, like life science, climate challenge, or Pandora project. But I think that at each university you will find different epistemic games. Even big game is some type of such games to engage our students in real work, in real scenario. Another system is PHET. This is dedicated platform for physics, chemistry, biology, mathematics, earth science. It contains, of course, some theoretical and practical knowledge, but also the way of providing this knowledge is quite interactive, fun, and it's not only dedicated for students. It can be also used by younger kids to practice these topics. When we look at open source hardware platforms, I think the quite famous is Arduino. I think that it's Italian, if I remember it correctly. Lego, Makey, they are dedicated to develop our own hardware system. So we will have some kit and instructions to deal with such objective to develop our hardware system. And open source software and programming environments, some of them are also can be also used by younger, not only by students. For example, Scratch but the other one are used rather by students. So we have Open Roberta, Snap for Arduino, or ID Arduino, and our students can practice how to program their own apps, IT system dedicated for different processes. So summarizing, of course, this was all. I only presented few sample IT system digital tools which can be applied to teach our students. This list can be extended. Some of them are very common, like Kahoot and different systems to involve our students, to interact with them. Main idea of digital learning is to allow us, like teachers, to control how, where, and when we want to learn. So at the era nowadays, it's also very important because we have to handle with teaching students like online. But there are different researches which confirm that online teaching cannot replicate every aspect of face-to-face teaching. It can encourage us to reimagine, redesign our courses. And the main challenge is how to focus on skills, but as well as content of such courses. And I think each university have to deal with this issue, how to provide value-add content for our students and how to teach them how to improve their skills to become a future engineers. And I think it will be the end of my presentation, especially that I feel that my time is over. So thank you.
Thank you very much, Joanna, for your very interesting presentation. Meanwhile, I'm informing the audience that everybody can put questions on different presentations, and we are grouping them to provide answers in the proper final slot, question and answer time. Thank you so much. Now, according to the program, is the time for hearing about the demand and competence and skill according to the perspective of companies. It's time of Mr. Jürgen Aronson, that is CEO of Implema. Implema is a consulting company in digital and sustainable business processes. The floor to Mr. Aronson, please.
Thank you. And I will share my screen here. Can you see the presentation?
Yeah, perfect.
Thank you. And I will give my view, both from my company perspective, but mostly from the customers we serve. And it's a large part of the mid-sized companies in Sweden. I'm from Industrial Engineering and Management at Linköping University. I'm from this generation, what is X, I think, 89 and to 94, and is also the CEO today of Implema and also one of the co-founders. My passion is to help the business to understand the potential of IT, to be the bridge between IT and business. And it's also, for me, my passion to grow people. And it's both in my own organization and it also out at our customers. And we are using and our strategy is also to get students into the company, and we train them and form them and grow them. And we have a trainee program every year, and last year was the biggest so far with 15 people. And so it's very important, this question, to have the gap between the university and the industry as small as possible. Few words about Implema. We are in the field of business software and helping our customers with digitalization. And our main partners is Microsoft and SAP. which are the leading providers of tools and software for us to help our customers. We're here, we've been here for 20 years and founded in 1998 and headquartered in Stockholm in Sweden. About 160 people and a turnover of 26 million euros. And we are not only helping locally in Sweden, about 30% of our turnover is sent overseas to help our customers around the world with the different sites and companies. So our customers, as I said, mainly they are in the mid-size field, which means turnover from 20 million euros up to 2 billion euros. A lot of them are family-owned, and the resources is limited today, and the skills in how to make their digital transformation and how to use technology. They don't have their own CDO, as I think a lot of larger companies have, and which means the Chief Digital Officer. And we are depending on your ability to advise and coach us in our digital transformation. That's a quote from Fredrik Sand, CEO for Aondas, one of our customers, producing protection gloves and shoes for the industry. So that's the role that we need to take out at our customers. And we're about 160 consultants, and about 25% has the background from industrial engineering and management, and the rest is a mix of economic engineers and system scientists. And what they're telling me is from my customers, the challenge is not the technology. It is to get our people or employees to use it. Another quote is, we think we are pretty good in continuous improvements like Six Sigma and Lean, but we need help to innovate. That's a challenge for us. Most of our companies and customers, they are organized quite traditional. The way that we've been organized for the last 100 years with a combination of hierarchical or matrix organization. That's where we do the production and logistic, and we can continuously do small improvements. But if we need to make bigger steps, if it's not enough with 10% improvements, we need to be 10 times better. How do we do that? This is a picture taken from Robin Teigland. He's a professor in digitalization here in Sweden at Chalmers University, and we work closely with her. And this picture shows the blue field is the area of what we know. The black field is what we know, we don't know. And then we have the big part, the yellow orange. What we don't know, we don't know. And that's the challenge. Imagine that we can get into this field and find solution here. That's how we can be a real winner tomorrow. But how to get there? We are taking a concept out to our customers that we create a parallel organization, a network organization, and we call the concept form of digital lab. Here is what we can take people out from the normal line business and have a room, a place safe enough to try, to learn, and to test and make prototypes of new things. It's an area where you can learn new things like machine learning, like AI, IoT, and that you bring in the business people and the business together. Here we can challenge each other, and here is an area where I think it's an excellent place where we need people, and I think from industrial engineering and management perspective to be really the bridge and to understand the business and bring in technology. And in this place, we can really roll out and scale improvements in a completely higher level than the traditional way of doing it. So this is the concept, and it's based on design thinking and different methods to be able to innovate. I think another area which are very important to address is, I think we heard about this for a while now, information is the new oil. And we have seen it in the field of the social media, you and me, our daily data that the big tech companies like Facebook are having the success on. And that's what we now see also a lot in business to business. All information that we have and that we can use to develop our business. And also here in this field, it's important to have the business understanding. And here is what I think industrial engineering and management fits in very well, to have the business understanding and at the same time understand the mathematics, the algorithms, and so on that you need to be able to dig, because you're digging in information and take this out and create business value of the information. So this is a demand, huge demand out of our customers today already, and that will increase. Some reflections from my side here during the project, and this was when I sent out the questionnaire. I sent it out to about 200 alumnus from when I started at the university, from this year age, and this is one of the answers I got back, the mail, and it's in Swedish here, so I translated it to English in the bottom here. But if we don't produce anything, then it's difficult to answer, and a smiley. And this guy was David Almström, who was started in the telecom industry, which was used in the end of 90s in Sweden, Ericsson, Nokia, and so on. And now he is in the software industry. And what he meant, and what I want to address, is that we also need to have a bigger scope when we're talking about higher education, not only Industry 4.0, we need to address other industries as well. And to further explain that, to give a view of how it looks in Sweden today and Stockholm especially, where we mainly work on. Our biggest customer today is Klarna, and Klarna is an app to make payments smooth on the internet. So it's only an app company, one app to make one click to buy things. And that's in the fintech industry, and they are one of the biggest players now in the fintech globally, and they will go in next time into the banking area to challenge and to disrupt this industry. Another example is Spotify, which are also an app, and I think most of them, maybe you heard about that, and to play the music. So this is industries, and I think another industry is the gaming industry. Minecraft, Swedish company, and they made a huge success, and Microsoft bought them 3 or 4 years ago. And what we see here is a huge gaming industry coming up. And what we heard also before here is not only why Microsoft bought it, I think it's also we can use this gaming into education and a lot of other industries, what we heard about. Another big trend I see out there is the trend of sustainability. And I think only in the last 12 and 8 months, I see a huge difference of the companies, and the top 3 prio for every company, both large companies and mid-sized companies today, are sustainability. And it's a big difference when I talk to my companies and the management teams and the CEOs out there. And one example is here's this company, H2 Green Steel. This will be a fully integrated, digitalized, and automated greenfield steel plant. It was announced 2 months ago, and they will be up and running 2024. So in 3 years' time, they will be the first in the world who will produce steel and with the neutral. And this guy here, Henrik Henriksson, he will be the CEO, and today he is the CEO for Scania. And when he was going to transform the transport industry to sustainable, they started with the electrical vehicle and so on, but they also realized, hey, our cars and trucks are made of steel, and they are 25% of all the CO emissions in Europe. So if we're going to do this in a real and to make a real impact, we need also to transform this industry. So they went in here to a traditional industry, one of the big industry in Sweden, and they starting from scratch, completely from scratch, exactly the same way that Elon Musk do with the Tesla and so on. They don't have any coming from traditional industry from the beginning. So what I want to say is that it's a lot of money and investment going in both to other industries and also to transform the traditional industry. And it's going in heavy speed. And that will be my also ending, this quote. What we fundamentally need to understand is that since the only thing we agree on is that the world is constantly changing, the only long-term sustainable strategy and competitive advantage for all the world's company is to learn things faster than the outside world changes and translate knowledge into relevant innovation. It is the only long-term sustainable strategy. Everything else has its best for date. From Google, this one. And I think that's what I think what we have to think about and give the students from the university the understanding that when you are ready from the university, it's only the starting point of learning. I was not aware of that when I ended university. And today I have the goal to spend 4 hours a week on learning new things. And I think I have to increase that, maybe up to 6 to 8 hours every week. So in the role I have as a CEO for the future, I will be more of a teacher than executive manager. Thank you.
Thank you, Jörgen, for your very interesting presentation and for the idea and suggestion you provide us. Now it's time of Anna Golas, CEO of Alcomot, yes, a company specialist in manufacturing metal and lead parts for traction and industrial batteries. Another point of view from the companies. Please, Anna, the floor is yours.
I try to share with you my screen. Do you see my?
Yes.
Do you see my my presentation? No.
Yes. Yes.
Yes. Okay. Okay. Yes. Okay. Thank you. Hello, everyone. I want to say something about my experience with people and his skills in Alcomot. I think I represent traditional organization, but we want to enter to path of Industry 4.0. What can we do? Some information about Alcomot. Alcomot is a medium-sized plant. We employ about 100 people. We work 3 shifts. We work 3 shifts, 5 days a week. We operate on the non-ferrous metal casting market. We cast lead. This is kind of our product. You can see my product in industrial battery. My kind of products you can see not all, but only the top of my product. We sell our products to the large producers of industrial battery in Europe and in the world. What makes us different from our competition is this capability to produce very small products, batches as well as big one, but up to a few thousand of pieces. We can produce this way because work in the foundry is manual work. We apply gravity casting. Therefore, the most important things for the quality and efficiency of our products are the skills of our employee and the condition of the molds. Our competition often use automatic casting machines, which are not suitable for the production of small series or for quick changeovers. But of course, we think about the Industry 4.0 and what can we do to get manual technology on the path of digital maturity? Does this type of production process have a future in Industry 4.0? Is the type of technology the only important factor when considering a future of the company in the perspective of Industry 4.0? I think we should look at this problem for several points of view. The clients, our competitor, our employees, and of course me as president and owner of this factory. My customers are not interested in change that will increase manufacturing costs. That is why introduction of automation is not an option because its result is higher unit cost of production. It is not profitable for small series and with frequent changeovers. We have already tried that. Our biggest competitors use production automation. However, we produce about 180% types of items, while they produce only a few. Unit production time of the product is about twice as long when using a machine than in our company. Besides, we are a subcontract of short series for them. For employees, automation would be a good solution. It would make their work easier. Lifting a cup of lead weighing between ½ kilo and of 2.5 several hundred times a day causes muscle fatigue, especially as it is a standing up job. Of course, switching to automation would significantly reduce the number of people working in the foundry. As for me, it's not too easy, but I am open to any solution that will ensure greater work safety for employees, improve the quality of our products, and guarantee consistency of production. Automation does it all, but the cost of implementation is unacceptable for me today because no one will cover them for me. Besides, when our customers accept something from us, they make it clear to us, even if it is the financial investment that is spread over time. It has happened before that way, even support to financial as such enterprises. However, they have never suggested the automation is of the casting process. So what can we do to enter the path of Industry 4.0? I think we should consider the areas of the company's activity that can be computerized, digital, and connect through information exchange systems. This area include warehouses, purchase, production, maintenance, quality control, according human resources. Each of those areas needs not only computers, programs, or tools that collect and display data. They need to be connected so that the information exchange is complete and needed at the right time. ERP class programs ensure this, and there is no problem with their purchase or implementation. But what will the ERP program not provide? I feel it would not provide the appropriate competence of employees who fill these systems with data and then use them to make decisions. Therefore, we started. I think I have to change my. We started computerizing our company by applying tools that collect data in a way that ensures its reliability and accessibility to many decision makers. It required raising the qualification of product support employee in terms of advanced use of software, Excel, and statistic tool. For the past 5 years, we have been conducting intensive training for employees. We have taught them to understand the importance of the collect data, sharing it, and working with it. It turns out, however, that this is not enough, because it is not good if they can work at the computer for 8 hours a day, but they cannot exchange information, make life easier for others, and ask for help. It turns out that the path to Industry 4.0 cannot ignore people and interpersonal relationships. In the case of my company, the biggest database will not replace human thinking and creativity. The past year of life in isolation has shown it very clearly. Systems may suggest solutions, but they will always be human-type algorithm solution. It is the learning that comes from the employee's experience that enriches IT programs. There are, of course, intelligent self-learning systems, but my industry is not at this stage of development to research for such solution yet. So, what is the biggest challenge for me in the context of Industry 4.0? The soft skills of employee. Teamwork, understanding others, appreciating others and their differences, willingness to exchange information and understand that we are in together, that we are in the same boat. Last year, we started training in motivation for change. Several key employees work individual with personal development trainer. We launched projects that involve product workers in solving problems. We discover talents among those who so far only criticize. Give people a fulcrum and they will move the earth. Thanks to such training, we also teach the employee proper understanding of information, the ability to find errors in data and jointly search for why they occurred. Our employees participate in visits to other plants with a level of technology much higher than ours. These are primary automotive factors. They pick up solutions from the best. It teaches them a lot. Some of my employees are Polytechnic University graduate. I am a graduate of management at the Polytechnic University myself, but I had to learn the soft skills after I finished my education by myself. How much easier it would be if these skills were taught in college. The abilities to manage projects, solve problems, conduct teamwork, communicate, manage time and change. Life in companies would be much easier. You could focus on your main area of activity. You can teach soft skills to an engineer, but you cannot teach engineering to a non-engineer so easily. In practice, it turns out that the communication process is the basis of any action, but it cannot to improve without the diagnosis of the communication process, without recognize and the effectiveness of the process and possibly the future communication process. What can the communication process be considered activity? In my opinion, when employee acquire several abilities. For example, perceptual abilities, organization, intellectual, forecasting, motivational, design, decision-making, intuitive abilities. As a boss, I should also be equipped with each of these abilities, which is not easy to accept, because it is also turned out that I, as a boss, also have a lot to do. I am not only supposed to demand, pay for training, accept good results. I also have to undergo a change. I have to show with my attitude what I require from my subordinates. Finally, one thing what worries me in the context of implementing the concept in Industry 4.0. Engineering and technology can adaptable improve the process carried out in organizations and enterprises, relieving human effort. but there is a dark side too. There are hackers out there who have the tools to break into factory system and take control of production lines, which are increasingly operated remotely. By taking control over production machines, criminals are able to damage property and even set machines against people. Such situations have to be analyzed carefully, and the safety of the process must be priority. Cyber attacks on servers has also happened in my company. Therefore, we put a lot of expenditure and resources to maintain this type of security. It seems like a simple technology. A hacker will not steal a machine, but they know how to steal this data, along with customers and employee data, drawing of products too. We can't allow that to happen. Losing the trust of our customers and employee is a loss that can be expressed in Europe. Thank you very much.
Thank you very much, Joanna. You gave us several inputs on what should be the further competence and skills that you required not after entering the job, but in college. And we will take care of your advice and motivation. Now it's time for the expectation from higher education by European students in industrial engineering and management. We will hear the voice of students, and I'm very pleased to introduce Maria Serodio, that is Vice President Education of the European Student of Industrial Engineering and Management STEAM. Maria, the floor is yours. Please.
Thank you very much. Let me know if can you see my presentation?
Yes, perfectly.
Yes, great. So as Professor Giovanni introduced, I'm going to be speaking about the expectations from the side of the students about industrial engineering and management higher education. So just some general context about me. Obviously, the best person to talk about expectations from students is an actual student. I'm finishing my master's right now in IEM as well. And I am the Vice President of Education at STEAM, which for context is the European Students of Industrial Engineering and Management. So it's an organization of students that does things for students, which has the vision of being the connector of the students of IEM with also the IEM Europe. And overall, we provide opportunities for the students in the areas of career, personal, academic, and intercultural development. So we gather people from all around Europe, 75 universities that have IEM degrees together for development and connections between each other. So the topic of this session, expectations from higher education by European students. By talking to a lot of students when preparing this presentation, I came to one very simple conclusion. IEM students' expectations from their degrees, it's quite simple. It's to complete the degree and feel prepared for their professional life. It's as simple as that. That's the vision that the student has from the time in the faculty. And in order to feel prepared for the professional life, there are several areas that need to be developed inside the student's path, inside the university. One of them is obviously soft skills that have been highlighted several times throughout this morning. Also, IEM hard skills, the actual content of the IEM degrees, the practical experience that we definitely need, not just the theoretical setting, the career path that we as IEM students can follow, and the understanding of the professional context of IEM at the moment. So also to complete a bit these opinions, I'm also going to include some results from a survey on student satisfaction that we ran during the last year with data from this same semester of 2020 for both bachelor and master students with a total of 160 participants. So we have an overall pool of answers from students from all around Europe. Going a bit deeper into each of the sections I mentioned, so soft skills. Several soft skills are extremely mandatory for any student that leaves the degree, from all the ways from teamwork, presentation skills, problem solving, networking. these things are going to be extremely valuable for our working life, and without them, we are just going to be professionals that are very weak in terms of interpersonal relationships and also the daily life at a company or in the factory. So unfortunately, soft skills are often overlooked by some universities, which is something that we could clearly see by the answers of our students. Only 15% of them said that the subjects that they have during their degree are somehow promoting the development of soft skills. So it poses the question, if we cannot find this in our higher education inside the courses we have, what do we do? Usually students turn into extracurricular activities, which also poses two main issues. One of them is that faculty's programs actually need to allow time for this. So if a student has an extremely demanding schedule, they are not going to be able to join these extracurricular activities that could be filling this gap that the university is not providing. And also a big problem also for the universities themselves is if the development of soft skills is turned only into the extracurricular activity sites, then there is no guarantee that the graduates of the degree will all have the soft skills developed, because it's something that is very up to the decision of each person to get involved or not. However, of course, some faculties have great initiatives. I made a small list of some that I've come across in the different faculties in Europe. There are some great things going on right now. Some universities that are providing ECTSs for people that are joining associations or attending and organizing big academic events. Some universities provide a lot of supports and even partner with the local student associations to together try to fill the gap. There are faculties that have actual courses focused only on soft skill development, or others that also include this soft skill development inside the actual subject. So while providing the content on a specific IEM hard skill, also including some evaluation parts and also some teaching part on the soft skill side that is also needed when transmitting this information. Then, of course, group work helps a lot with teamwork and presentation skills, joining different projects, having even projects with people from different degrees. It's also very rich. And one that I personally find extremely interesting is to allow students to have contact, not just with students and professors, but also from people from different scenarios. For example, having a subject where they have to enter in contact with a CEO or an entrepreneur, or having a session by a professional trainer. This kind of different experiences also allow students to interact in a very different scenario than what they are used to. Going now into the IEM hard skill part, also extremely important for the formation of any industrial engineer. IEM in general has very different areas when it comes to itself as a degree. From all the way into the more engineering side with the basic sciences, the engineering subjects, also to the side that is a bit more related to the management side, to the business perspective, with the management topics and also some core industrial engineering topics. And at least what we feel as students is that there is overall in Europe a very fragile balance between what is the engineering side and the management side, because there are some courses all around Europe that have way too much engineering compared to what will actually be the professions that people will follow, so that they don't get enough insights into what are actually the skills they will be needing when they actually get a job in the area of IEM. And on the other hand, there is also universities that have too much management and don't cover almost the engineering side, which then of course creates a very big lack in terms of the knowledge of tools and softwares and the development of logic thinking. Overall, we try to also bring some direct quotes from students that filled also our survey and in our focus groups. Some students feel that they even need to go look for online courses and a lot of other materials to try to complement the education they have on topics. For example, in this case, it was data science, that the students felt that the university was not covering this area in a way that it was enough for him to follow a career there. Other students feel like some universities don't embrace technology enough. The world is changing, and we really need to make sure that the universities are the first ones to keep up with that and to promote that strive for technological development also on the students. And also some students that overall get very frustrated with spending one semester or 1 year studying and learning how to do processes by hand that are completely obsolete nowadays. And in the end, learning how to do things by hand, forgetting them 1 year later, and not even touching the software that is actually used in nowadays to do the exact same thing in a way faster, in a way faster way. So overall, students want something that is updated. They want updated knowledge, they want updated softwares, they want things that are in line with the technological revolution that the world is facing, and also applicable knowledge. No student wants to spend a semester learning something that they do not see at all how it is going to be applied in the real world. So overall, we expect universities to have a very proactive approach, understand the markets that they are operating in, understanding what are the needs of the students, the needs of the companies, instead of a reactive approach of just updating themselves and keeping up with the trends if they get complaints from the students or feedback or from the companies. So really being an initiative that comes from the university to keeping on updating themselves, providing the best knowledge possible, and providing something that is updated and necessary in the modern society for the students of IE. We went to the research as well. What are the main skills that are demanded from industrial engineers? And obviously, industrial engineering has a wide variety of different areas that people can work on, all the way from quality into project management, sustainability, corporate business, data science. There is a wide plethora of jobs that people can have, and also a very good overall employability rate for students. But also they expect that these areas, even though they are very wide, they are able to explore them. So for example, a student that knows in their third year or when they are starting the masters that they want to have a career on lean and on quality management, to be able to have more than one single subject on that. So students, when they start to learn what they want to do in their lives, they expect to also have the possibility to dig deeper on those areas, to have something that the university provides that is actually helping them to develop and creating the path that they aim to follow. And also, of course, they expect that the things that they are learning are in line with the current demands of the market. So as I was saying, a student that joins a prestige university is expecting to learn the things that actually he will apply in 2-3 years when he leaves the master's degree. Then coming up to the part of the practical experiences. It's extremely important for all students, as all the professors know, to actually apply the theoretical concepts in a practical way. So with experiential learning, making the learning stick on the mind of the students. Several possibilities in here. Case studies are a great way. Incentivizing students to actually do research, either alone or also with the professors, is also an extremely interesting option to make them research more about the fields they are interested in. Multidisciplinary projects that join things from different subjects. Incentivizing student competitions where even professors might want to be mentors of the teams. Using simulators, for example, having a simulator of supply chain or having a simulator of a company to make students actually interact with daily life decisions. And of course, actually incentivizing that students go to the companies and do a project in partnership with someone from a company or in a factory setting, for example. And overall, I think it's also very important to highlight that in our side, we really value the learning that goes on during a degree. We really value the topics that are there, and we really want to explore them further to become good professionals. And that becomes a bit complicated if the subjects are very exam focused. So this was something that was referred by a lot of students throughout the year. People even when we ask for feedback on what their expectations are or how things are in their university, they always say, exams this, exams that, when in reality, exams should not be the center. They are just one extra step of evaluation. So it's very important to also have the subjects centered around the learning experience and what people learn and what the skills they develop, and not just on the grade of an exam. In terms of career paths, wide variety of career paths, but students don't really know what they can do sometimes when they enter a bachelor or a master's. And even if they know the name of the profession, sometimes they don't really know what actually the profession means. So a person might say that they want to work in logistics, but if you ask them in what part of logistics, they just say, I had a subject about warehouses and it seemed nice, it seemed interesting. So people don't have a deep understanding on what actually a career path can be in IEM area, which is something that definitely universities can play a big role also on helping the students figure it out. And finally, in terms of the IEM professional context, students really expect to be close to the future working environment and getting to know it a bit more personally. This means that they want to understand what are the real life applications of what they are taught in class. And also they expect to have direct contact with professionals and their daily working environments. This is something we also asked to our students, and unfortunately, only 12% of them said that they were feeling prepared for their first job, which is a bit of an alarming percentage. So as a sum up of everything that I talked here, students expect actionable knowledge to be given during their university, knowledge that is up to date with the needs of the job market and the digital transformation, and to be developed in core soft and hard skills that are needed on today's IEM world. So thank you very much for your attention, and I hope you enjoy the presentation.
Thank you so much, Maria. Very, very interesting presentation. I had some difficulty to take notes of all your inputs. You are really, really interesting. Just to summarize, I would like to share with your idea, that is also the idea of companies, I should say, to transfer the knowledge from extracurricular activities to curricular activities, in another way to anticipate what the company needs. Thank you so much, really thank you so much for your presentation. Now it's time for 15 minutes of break, and we will start 11:15 sharply. Thank you. See you in a few minutes. Hi, Jan-Erik.
Hi. So.
Hello.
A couple of minutes more.
Yes, we have to wait a little.
Hello, this is Fabio Giuliani. Hello, good morning, everybody. I received a message. I cannot activate my video because it says that the host has stopped it. Can anyone do something for that?
Yes,
or should I simply reconnect?
Okay, I will call him. Ciao Roberto.
Mi vedete?
Ti vediamo
Ciao,
e
Roberto.
ti sentiamo perfettamente.
Buongiorno.
Ciao Marco. Buongiorno.
Buongiorno Fabio. Buongiorno. Good morning everybody.
Good morning.
Good
morning.
Video.
Hello everyone. Good morning.
I think I will reconnect because the video seems to have some problems. So
sì, certo.
I'll be back
Un panelist.
in a second.
Sì, esatto. Dr. Giuliani, you can now share your camera. Vabbè, può lasciare anche questa slide.
We are still missing some colleagues, aren't we?
Yes, Peter Platt. Peter, are you in?
Peter is there.
Sure, I mean, of course.
Antonio? Antonio Fabio? No. Carlos? No.
Yes, here I am.
Where are you? I can't see you.
Let me see.
Deve
No,
mettere
my video is stopped by the controller from the conference. But can you hear me?
Roberto.
Hello?
Yes, we can. We can
hear you. If it's Roberto talking, I don't know who's talking.
No, I'm here.
Yes, good, you're there.
Yeah.
Let's see again who we. Antonio Fabio, are you there or not? Apparently not. Peter is here. Marco is here.
Hello.
Yes. Carlos.
I'm fine.
Can you hear me?
Carlos.
Yes, can you hear me?
Yes, but I
Hello?
can't see you.
Yes, because I am trying to start the video, but it says that the owner of the conference stopped it.
Really?
I'm Fabio Giuliani. I have the same problem. Hello, everybody. Same problem for my video.
Vedi che
Aha. So we have a technical problem apparently among some of the panelists that we might solve
Yes,
quickly.
Maybe I will stop the connection and I will start again and see if it works.
Okay? I did the same. I tried. In my case, it didn't work. So video is still stopped by the host, it says.
Yes, this is what it says.
Now it's working. Now it's working.
Antonio is visible. Okay. No problem. We wait for Carlos to have the same solution as Antonio had. Here you are.
Now, let's see.
Technology is fantastic. Someone.
Can you see me?
Yeah, we can see you and hear you. Excellent.
Okay.
So we are 6 people now here. And if I ask Janne to take away the screen text you have behind us, so we just have the pictures. Janne, are you there?
Yes, please.
If you just take away the front page of the leaflet you have behind us.
Okay. That's not me, but it's the host.
Okay, because we can have a full picture of the panelists, I hope. Now I only have a small picture of everyone.
Okay, just a second.
So, perfect. Perfect. Now I have the panelists in front of me. You see me, and the audience will see you. That's
Yes.
very good. 2,
Okay.
4, 6, 7. Yeah.
Okay.
Good. Welcome here, friends, to this panel discussion that we are going to run together now for 1 hour and 40 minutes approximately. And we have 50 people in the audience around us who will also have a chance to take part in the discussion if they have questions. They can just mail us or on the chat, put the questions there, and we try to see when they come in so we don't miss them. But there's a good chance for you to say, intervene in this discussion if you want.
Mm-hmm.
We are going now to organize this panel session in the following way. I say some words why we have the panel at all, why do we sit here. Then I give the members of the panel a short while to introduce themselves very briefly, your background and how you can have, to say, contributions to the discussion from your profession. Then I will give each panelist a chance to give a general and personal view on industrial engineering and management programs or education, or how you have experienced these kind of candidates. After that, we start a discussion on the SWOT analysis to see if we can synthesize some issues there for the future designing and content of programs in industrial engineering and management. And finally, we open the floor for more questions from you who are attending, and we also have already received a question that we can take at the end and have an answer on that as well. So that is shortly my way of organizing it. And why we sit here today is just to reflect a little on what's going on around us with a new paradigm in production referred to Industry 4.0. And that requires some kind of reinforcement of the University Industry Alliance when we design the content and the goals of future higher education programs in industrial engineering and management. Because we have to face the changes going on around us, and we have to accommodate our programs in a way that our students will have the best chance to have a good career in industry when they are ready from university, and also to meet the requests you have in industry on what kind of, say, product you would like to have from university when students are ready. So with this very exclusive panel, we are going to discuss these issues together, and you will give your standpoint and background based on your own experience. And there are so many issues to, say, dive into here. We can't absolutely not cover all of them. And we have heard very interesting presentations with a lot of things that we could hook on if we want. But I think take it from your end, from your experience, from your personal view. That is the best thing. Then we can hook on what we have heard from others as well. But these PowerPoints we will get later on, and we can read them again, and we can learn from them a lot. I say a lot we can learn from them. So how can we strengthen the content of the programs in industrial engineering management to meet your expectations as company leaders on the students being examined from these programs? And we are going to do this in the format of a so-called SWOT analysis. And we talk about strengths, weaknesses, opportunities, and threats. In the picture we have to face when we are going to look into the future and the redesigning of our programs at university level. So that is why we sit here, and we are very excited now to listen to your experience, to your ideas and your proposals, perhaps, how to get further in this issue. But first, a short round when you present yourself, your short background and experience in this field we are going to discuss today, higher education programs in industrial engineering and management. So I give the floor to Roberto.
Hi, Roberto from Bosch, South Europe, based in Milano. I've been working at Bosch since almost 18 years. And in all those years as a Bosch, we have developed important cooperation among the university and, of course, with the goal to hire the best talent for our company. So the subject of today's discussion is a very challenge for the company and a passion also for myself.
Thank you. Marco? You must.
Hello, good morning, everybody. My name is Marco Tais. I'm acting here this morning as president of MADE, which is one of the 8 competence centers launched by the Ministry of Economic Development in Italy a few years ago, and MADE is made by 44 partners. Bosch is one of them also, so I'm very proud to be this morning with Bosch here. And what I will do, I will report my experience in Industry 4.0 and my perspective from the activities that we are doing here in order to support the digitalizations of companies. Thank you so much.
Luis?
Good morning, everyone. First of all, thank you also for the invitation for attending this session. So my name is Luis Viudes. Aside from being a student from the University of Seville, last year student from the degree of Industrial Engineering and Management, I have been for the past year also the president of the European Students of Industrial Engineering and Management. And together also with my VP of Education, we daily strive towards improving what is the IEM content that we are providing to students also. And yes, very glad to be here.
Thank you. Antonio?
Good morning, everyone. Thanks to Professor Mumolo and to Polytechnic of Bari for this opportunity. I appreciate also because I graduated in Polytechnic of Bari, and so I have a double reason to be happy to be here. I'm the general manager of Bosch for the region Italy and Greece, and of course in the company we have a huge need for this kind of cooperation between companies and universities or academic world in general. So I was happy to listen to the first part of the conference and looking forward for this follow-up. Thank you.
Carlos?
Yes, hello. Well, I studied Master of Science in Industrial Engineering in the School of Engineers in Bilbao. And I have been working in industry for more than 30 years. I started like a technician in nuclear engineering, then in steel optimization with industrial computers. And then, I will explain later in the presentation, I found out that to do things happen, I needed to go to the executive area. And this is what I did. I have worked in ArcelorMittal as Vice President for Logistics, in Gamesa, as Director of Strategy and Business Development, and another Chinese company in wind and solar energy. Right now, I am working in my own company, and I am assisting companies and participating in innovation products that I will explain later.
Thank you, Carlos. And Peter.
Yeah, thank you. First of all, thank you very much for inviting me for this panel. For my professional background, I spent 16 years in automotive industry here in Europe and in the United States. And since 11 years, I'm teaching and researching on manufacturing technologies. And I'm the course director for a bachelor program and a master program. So with that, basically, we are impacting, strategizing, formulating the needs of the students to be educated to match basically the needs of the companies.
Thank you. Dear friends, I hope you don't feel angry on me that I just use your given name. That is a Nordic way of communicate, and it's easier to use given names and full titles and surnames. So I continue with the given names if you don't disagree with that. My own background is I have degrees in mechanical engineering and production economics. I have been head of school for 16 years and developed programs in this area, industrial engineering and management, and renewed them a lot at my own university during these years. I also been appointed by the European Commission to be Bologna expert for Europe and the ECTS counselor for Europe. So that is my background. Today I am running big projects financed by European Commission on knowledge transfer into countries outside Europe. So now we know who we are, and I think that you should give as panelists your personal view on or experience on programs in industrial engineering management as you see it from your end. And that's the first introduction of yourself and your background in this field. So I go around a little randomly between you, and you give your vision. And I start this time with Antonio.
Yes, thank you, Jan-Erik. As I said, there's a big need of this kind of cooperation, and this is also given by the experience that I had in several fields of the company. You know, Bosch is working into technologies. I have to use the plural because we are active in so many industrial fields, and not only industrial, also in research and development. And for this reason, this wide portfolio of activities cannot be exploited without the cooperation with with universities, with the academic context. And I think we did this improving that over the last years, but it is not yet enough to exploit all the potential that we have. So for sure, compared to when I made my experience at Politecnico of Bari, many things have changed in the right direction. And we really took advantage of that in a company like ours, with a lot of exchanges. And I was active and I still am in the production plant, so very close to the manufacturing. And so, of course, this boost towards digitization was also possible because of this cooperation with universities, of having students here making, for example, their thesis and so on. As I said, this is of highest importance, and I also like to mention another example, what we are doing in Milan for sensor design, for example. This is also possible through this kind of cooperation. As I said, we are on the right path, on the right way, but there's a lot to do still to increase and improve this kind of synergy.
Mm-hmm. Thank you. We jump to academia. And Marco?
Yeah. Let me say a few words about this the fact. First of all, I think that COVID has been an accelerator of the digitalization of industries. It has made evident that especially SMEs, in order to be competitive, or let me say, in order to survive, which is even worse, they need to go digital. So I think that what we need to do is to invest in spreading more the word towards younger generation, in order to make them more interested towards industrial engineering, toward digital technologies, and especially to be more interested in SMEs. Because the risk I see here is that SMEs will not be able to find the right people with the right competences. Younger students or younger graduates are more attracted today by large multinational companies because they are able to provide up-to-date technologies. We heard what Antonio Fabio just mentioned that they are doing, and they are an example which is followed by many other companies. The Industry 4.0, the fourth industrial revolution, is really creating a digital divide between large multinational companies and SMEs, and I think we have the responsibility to educate and to train people who are also able and willing to work for the SMEs. I think this is one of the most important challenges that we have and we are facing in the near future. And this is the reason why in my university here, Politecnico di Milano, we are revising the curriculum, we are revising the content of the courses in order to provide not just, let me say, theoretical know-how for engineers of today, engineers of the future, but also to provide a more practical and content-oriented know-how in order to make the students, the graduates, ready to be used, let me say, by SMEs.
Thank you. Carlos?
Yes, well, I thought I was going to make the presentation before, but I can explain that a very practical tool for the collaboration in between the university and industry are the R&D European programs. Right now, I am working in one of them as coordinator, and with Professor Ordieres and his team, and we are introducing these digital technologies in several industries, 3 multinational companies. And this is a very interesting way of putting the collaboration in between university and industry in a practical way, because these kind of projects, if they are true projects with practical results, allow the involvement of students from university. In this case, Mr. Ordieres put doctorate students from industrial engineering, and also the people from the plants, from the factories, not only operators, but mainly the managers that are the ones that are going to implement the lessons from these kind of projects into the day-to-day experience there. So this is a very, very interesting tool. And unfortunately, it depends much on the top executive of the company's vision and will, and also of the specific professors in the universities. But if this could be, and this project IE3 could be a way to do it, this could be more institutionalized in Europe. This could be a very helpful tool to increase the collaboration in between university and industry.
We jump to academia again. Peter?
Yeah, basically the scope of the university is threefold. We are supposed to do research, we're supposed to educate students and contribute to the national or greater region society related to culture and economy. Let me give you examples for all 3 areas. The companies want to get something out of the university. They want to get know-how, relate to Industry 4.0, and they want to get well-educated employees. So it's a bi-directional sharing of knowledge. It's a mutual benefit industry and academia has with complementing skills which mesh together. The industry should provide academia with the industrial challenges. So sharing with us the industrial problems and providing funding allows academia to do the research. Relate to education, what we are doing in our programs, we have a lot of external teachers who teach projects, project management, assembly machines, case studies, and provide industry internships, complementing with those skills our theoretical academic teaching about digital factory planning, programming, robotics. In the area of 1/3 of our teaching is from the external industry. Similar in research, the funding which refers to my team is approximately a quarter, which refers to industrial funding, and the residual from the mentioned European projects or national funding or university internal, which gives a pretty good mix. So, and the last item before I hand on the word is a call to action for companies. There is the opportunity for strategic partnerships. At the University of Luxembourg, we have we just talked about ArcelorMittal. There is a chair of facade engineering sponsored by the companies. Paul Wirth is just financing a chair about hydrogen research. And my team is sponsored by Eurocomposite, related to lightweight design manufacturing.
Let me hear what the students say now, please.
Thank you. I would like to start picking a bit what Professor Peter Flapper just said also. I think it's very important those partnerships to happen in also order to strengthen what we see as the IM degree of the future. So in terms of from what the student expects of learning how to deal with those practical problems in business industries, that of course the focus lies on how to find those solutions to problems while combining a bit of those technical and scientific design perspectives in general. So I believe that in terms of what the general IEM degree should aim master's program is to train indeed those engineers to acquire a bigger overview of all the primary and secondary businesses process that must exist inside the industry, and yeah, especially also respect to those design and technological product processes that were mentioned already. And yes, it should aim after all to train a bit what an industrial engineer should perform on a very higher level, and give him those solid preparations that we already, my colleague Maria mentioned in the morning, in terms of what is the engineering sciences, trying to cover all the different fields from production management, industrial logistics, quality engineering, hygiene, safety, work, technology, systems. So indeed, intending to provide those future professionals with some of these previous, not only fields of industry, but also connecting it with some basic skills that also that engineer should perform, such as being able to analyzing a project or improve and optimize different processes inside the industry. Even having some leadership techniques and more problem-solving competences for its teamwork. So yeah, after all, complementing a bit what have been said here, aiming to have those trained engineers on a higher level.
Finally, Roberto, you give your
input. So talking about SWOT analysis to renew, to rethink to higher education in the industrial engineering, from my point of view, of course, all the colleagues mentioned the importance of the cooperation between companies and university. So my experience on that we have very excellent example. I used to work with Gianni Mummolo, the University Polytechnic of Bari, Polytechnic of Milano, where there are also a kind of proactive approach, where a university, they approach companies, and of course also from company side, we need to be open to invest time and in some cases also money for define new project and giving the opportunity of thesis. Hearing also Luis and Maria from the student side, my experience also as HR is also the balance between the technical competencies and the so-called soft skills. My experience, having hired thousands of engineers in my career, the technical background, especially when we are working in large multinational, is something that we are able to fulfill with the terms of Industry 4.0, where we should really work very close or are in the soft skills competence of communication, teamwork, collaboration. And the second, in terms also of renew of the higher education in the industrial sector, we need to make a common effort between company and university to be more attractive for the female students. I think that the gender balance in all sectors is very important. And unfortunately, if we see the percentage of the female students that they are deciding to select an industrial engineering academical path, at least in South Europe, but I have also data for entire Europe, is very, very little. So how to be also attractive for the young generation, especially the female, to select this kind of career path and study path. Thank you.
Thank you. Well, we are talking about industrial engineering and management programs, and we have audience from all Europe with us today. And we know that the design of these programs is different in different countries. We don't have the same design. We call the programs industrial engineering and management, but we design them differently in different countries. For example, in my country, we don't have internship. In Italy, internship is very important. In Spain also. We also talk about a 5-year program ending up with a master's degree in industrial engineering and management. There could also be a 2-year program ending up with the same title. Sometimes a 1-year program ending up with the same title in UK, for example. So there are different approaches how to run this kind of education. But we talk today about more generic issues around the program. We can't go into the details how different countries are doing because they have the right to solve these design problems as they want, of course. We also have to think about how can we match the demands from industry with the possibilities to deliver from academia? Or should we deliver what they demand today from industry? Or what kind of time horizon do we have when we educate students? Because if we start to educate them from demands of today, when they are ready and come to the market, these demands are different perhaps also. So this is another dilemma that we sit with when we have to design programs. And we can discuss different things now because we have to go through the 4 issues of SWOT and see how we can approach the different things here for the future. And now I let you ask the word when you are ready to say anything. So we don't go around as I did now. It's a more free, open discussion. When you show me your hand, and I try to make a notice that you would like to enter and say words. So if we start with a brief discussion on what strengths do we have today in our programs? What strengths do we have in our collaboration with the industry? What is worth to take forward among these issues? Then we talk about the problems later on with the weaknesses. Now we concentrate on strength. What is good today? What do we don't want to give up? because we have such a good experience of that. That's so beneficiary for everybody to continue like that. I would like to hear your words on that. What do you see as strength in the designing of programs in our field today? Who would like to give inputs here? Please, yes, Antonio.
Yes, yeah, we're talking about, when we talk about digital, of course, we're talking about tools, we're talking about instruments. What is beyond those is the process. And this has to be, it looks very trivial, but has to be reminded all the times, in my opinion, not to focus on the tool, but to focus on the whole cycle of what we're talking about. So in this context, I think one of the biggest trends I see is that the lean manufacturing as a methodology is a starting point, and it has to be taught into universities before using any kind of tool, including digital, of course. What we normally do, we talk about process mapping, process design. We map value streams with mapping and design. We want to draw the desired state. And this is the basis. This has to be taught to students to think about the process and what we want to do. And after that comes the tool, comes the instruments that have been developing over years, of course, and now are going towards this kind of strong and marked digitalization with AI, for example, and Internet of Things. But I mean, I think what universities do at the moment in teaching lean manufacturing to students is for sure a pro that I see, and a strength that I would like to underline.
Well, Antonio, should always a program in industrial engineering and management be based on mechanical engineering issues? Or could this program have other bases, for example? Just a provocative proposal here. Who would talk more? Please, raise your hand. I will have to inputs from you.
I think Professor Marco.
Yes, Luis. Or
I think Professor Marco was first. Yes.
Marco, sorry, Mr. Marco. Go on.
Yeah, no, thank you very much. Let me first answer to the question of what is the strength of our programs. I think that one of the most important one is to be international and is to be given in English. I think that this is really preparing our engineers for a globalized world, and having them to the opportunity to study in English is not because English is the language of the future, but it is because in this way we have international programs and we are able to have students coming from all over the world. And an industrial engineer should not also be a technician. An industrial engineer should, let me say, use and possess all the soft skills which are needed to face the challenges of working in a multinational, multicultural, very diverse environment. So I think that this is an issue that we have to work on. In terms of your provocation, I think that the basis of industrial engineering was mechanical because that was the most important technologies decades ago, or let me say, but today there are many other technologies which I think need to be considered by an industrial engineering. I wouldn't be able to say if mechanical background is more important than digital background, right? I would say that mechatronic is there. Mechatronic is the future. Telecommunication is the future. And therefore, we need to prepare engineers with a strong background in any of the enabling technologies, which is not just the mechanical engineering technology. So it's more challenging for them, right? And that's I think that the bachelor, because in our university we have a bachelor in mechanical engineering, we have a bachelor in telecommunication engineering, we have a bachelor in electronics engineering. I think we should create a new bachelor, which is already having multi-dimension engineering practices, know-how, and technology, in order to prepare them for let me say, a great and very open-minded Master of Science in Industrial Engineering. It's a challenge, anyhow.
Mm-hmm. May I just say, how far can we go when we try to give the students as broad engineering competence as possible? Is it a risk to do that, or is it a challenge? I mean, what kind of basis do they have to stand on technology, and from an engineering point of view, to be a real engineer? What is an engineer tomorrow? And how much of profound knowledge do that person need to be able to stand up and say, I am an engineer, please respect me? Okay, Luis?
Thank you. So I would maybe start by answering you that question. I do believe that there's always that dilemma of knowing what should we do. So specialization, or rather going for a more broad, how to say, training on these students to become more multitaskers in the future in terms of areas that they can work upon. I believe that maybe not good, jumping directly to the threats, but that can be also allocated into a threat. So this continuous crescendo of areas and scopes of the IM field, or in terms of having those diverse areas that can be included here. One thing that I can tell for sure, and things that there are strengths on the current IM. So agreeing with what Professor Marco just said in terms of having that degree on English, that's for sure. I know we said in the beginning that we were not going to concrete cases, but I felt myself in the situation of having it traduced also for technical terms. It brings us a more difficult approach whenever we are going to a more professional life, that's for sure. Also, the increasing at the moment of the incorporation of case studies during the course. So giving these assignments to students about analyzing some specific cases about organizations, groups, persons, issues, and then seeing exactly with students where those industry issues, how can we explain those elements and complexities of the different cases, that's for sure, and how to apply also that theory there. One thing that I think it's benefiting a lot also to what we are trying to develop, it's also the increasing introduction of simulation games and also gamification tools also in the course. And last but not least, one thing that I think is extremely important also for us, and also coming back to the question that was raised in the beginning, it's the fact of mixturing those different approaches and signatures and broadening a bit what the course might be.
Mm-hmm. Luis, your colleague told us that you are not so happy with what you receive today from the training programs you participate in. So there must be some problems there for the future as well. We come back to that perhaps, but we look now to Peter, what he has to say.
Yeah, let me switch on the microphone. Basically, the issue of language was already mentioned, and in Luxembourg, it's not only English, but Luxembourg is between Germany and France. So at home, our students speak French and German, and in the master programs, then we educate them in the language of industry, which is English. So all alumni of our university are really versatile in regard of language. So I think that's one strength which I want to also add or reinforce here. What I think is an advantage is if you have financial aid for R&D, which has the right mindset. We're not only going for fundamental research, but also going for stimulating cooperation between academia and industry. Luxembourg has a pretty stable political environment, and since long years, the aid for R&D is enforcing industry to collaborate with academia, which is pretty nice. That goes along with the companies here. Luxembourg is expensive. So, and that's why the companies are really in a high-end segment. They are producing high value-added goods. Thus, they are looking for the cutting-edge technologies. They're hungry. They're really eager to cooperate with us here in the university, and that is very advantageous to then shape project, case studies, and so on, like Louis said before.
Mm-hmm. Friends, if you use your virtual hand, I now can see it on my screen. So please do that. I try to look at that little sub-screen all the time to see the hands there. Roberto's hands is now up, and when you have had your word, take it down again so we can just have new talkers. Please, Roberto.
Yes, thank you. Of course, as a strength, I'm talking here, particularly in Italy. You mentioned the opportunity to make internship during the study that will help the students to improve his or her technical competencies and to make first experience in the, let's say, in the industrial world. Of course, the combination between the technical background that during the university program, the students, they are achieving with the so-called, Luis was mentioned, this multitasker approach, which is, by the way, in most of the multinational and also other companies, probably one of the best competencies that we are looking forward. So as a strength, I really see that during the academical path, the students, they are really receiving a common understanding about all, let's say, the technical background. So this is my contribution.
Thank you, Roberto, for that. I feel a little bit ashamed talking from my end of the world that we have given up all kind of practical training, internship in our programs in the Nordic countries. Why did we do that? Yes, we said that we need these weeks for training of the students in academic subject areas in the best possible way. And we wanted to have them at academia all the time, all 5 years, and don't send them away for internship as a part of the degree requirements, so to say. Students, they do their own internship in the summer holidays, but it's not accredited in the degree in Sweden, in the Nordic countries. So that's a big difference between us. And I understand, Roberto, when you talk about these internship, how important they could be for this alliance between academia and industry, especially for the students, because they are the beneficiaries here. They enjoy this kind of training in a, so to say, organized way that we don't give them. They take a summer job wherever, but it's nothing to do with the degree they are going forward to receive. So we have differences again. I see now no hand up here. Let me check. Peter. Yeah, Peter. Thank you, Peter.
Yeah, basically, Jan Erik, what you are saying about the industrial internship, I experienced being educated in Germany, coming from with a German background where half a year is mandatory, half a year of industrial internship is required during education, and coming to Luxembourg, which lives off banks. Luxembourg is a financial country and nearly dirty. Sorry for that one. So an industrial internship is not really rooted in the national culture, neither in the country nor in the companies. So it's considered dirty. It's considered not needed for academic. Similar, like you just said, from the Nordic country, it's not considered for an academic education. And I'm pushing for that one really strong to get it offered by the companies. And what the companies then offer is fin d'études project. It's a thesis, because of course the company wants to get something out of it. If they get a almost finished student, they would like to have the student to work as engineer. But an industrial internship is standing on the shop floor and doing grinding, doing some not tie work, blue collar work, and learn what's happening on the shop floor, which we cannot educate from academia. So I'm suffering from that, as you can hear from my talk.
That's right. What we do in the Nordic countries, we let the students do their master's thesis work half a year. 99% of all thesis work is being executed in industry, together with industrial partners. So that's, as you said, we can deliver to industry some result of a problem that they would like to have experience, have researched on, so to say, and they get a report on that. So that combination, perhaps, writing thesis in industry is not an excuse for internship, but it's a way to let the students get acquainted to what's going on in industry. When they are on the edge of the work market, they're going to go there next day, so to say. Now they can train on real problems. Could be good for them. What you say, Luis? You have the word.
Just wanted to also introduce a new perspective regarding the internships. So I was born and raised in Portugal, but I made my degree in Spain, in Seville. So I have both cultures, academic cultures, very, very fresh. So comparing it a bit, what it is, that culture in Portugal, where you reach your last year of masters and then you have a full semester, where every student is very looking forward to develop that internship in industry and after all making its thesis. When it comes to Spain, in Seville, that internship, although it's not mandatory, okay, it can also be replaced by another subject, such as, for instance, history of the engineering. So I would say once someone it's graduated, okay, let's say I'm applying for a position right now, I believe that the concept of the perspective of someone that's hiring that student that has developed a whole project thesis in industry for 6 months compared to the one that had a subject regarding history of the engineering. Not talking from the company perspective, but I would assume that, of course, the difference between one another, it's quite impactful in order to, when it comes from the perspective of a company.
Well, it seems to be a little bit difficult to talk about strength because they are so clear. We think that we have the best program that we run today, perhaps. So it's difficult to highlight what is good without being too strong in your own, so to say, promotion of the program. But anyhow, I think that strength must be taken on board, because if we are going to develop and change the future programs in industrial engineering and management, we can't throw away what is good. We must build on what is good also, of course. I mean, people, you are from industry, 3 of you, and in your work, I think that you always try to put your most effort on what is good and don't waste your time on what's not good. Because if you waste too much time on what's not good in the company, you have a slow way forward. But if you put most effort on what's good, it's much easier for you to get off and have a better profit, so to say. So that's in academia the same. We must see what is good also. Don't throw that away. Keep it, but make it a bit better, perhaps. But now I see, I have a hand, yeah, Carlos. Please.
Yes. Well, I wanted to, talking about different experiences in the different countries. We have a clear example in Spain, in the Basque Country. Mondragon University is a university that is in very tight relation with the companies. In fact, it was originated by the cooperative movement in the Basque Country in the 60s, I think, of the previous century. And right now, the group Mondragon has 230 companies, and they have the University of Mondragon. The students make practices in the companies continuously, and they interchange knowledge with the people that are already working there, and they learn about the demands of the industry and take it back to the university. This is a real example that is running for many years already, and I think there are many lessons to learn from this experience. And they have become international. Of course, they have agreements with a lot of different universities also to make their students to do practices also in foreign countries. And I think this is a very interesting, the practical model to learn from.
Thank you for that. This information, Carlos, what you have experienced in your country. Sometimes I hear people saying that we can't be too close to industry because we must be standing alone as academic partners, doing our research and our problem solving as we find best for us. And then if what we come up with is good for industry, they can enjoy it, so to say, or take it. Is that a kind of approach that you sympathize with, or do you say that this is completely wrong? Peter.
Let me switch on the microphone. Yes, I frankly speaking, I completely disagree, because we as teachers do serve industry by educating engineers which match their needs. And in order to come up with the real requirements from the industrial partners, we need to interact with those guys. The industry is moving so quickly, especially in Industry 4.0. It's a fast-moving topic. So if I would rely on my old knowledge from 10, 11 years ago from industry, that is outdated. That's good for bachelor, that's good for foundation, for the which applies everywhere. But for then educating, I think we need to wrestle with the companies. Let me add one more suggestion how we do it. We do research projects, PhD projects, which are going for 4 years, which gives you a lot of length and also outcome, as the students are, first of all, good, second of all, work lengthy. And under these PhD projects, we shape master projects, which are all together with industry, but in the premises of the university. So the exposure of the bachelor and master students is, let's call it, a little bit indirect to industry. And it helps the PhD students to learn to manage their team, to lead the bachelor and master students, because I don't do it myself, I delegate to the PhD students.
Good. Roberto, now we hear from industry what to say about this.
Yeah, I also disagree when, from university side, we say that we can be contaminated from the industrial sector. I see that the preparation with internship, thesis, and all programs is also from an employment point of view, a social, let's say, commitment that also from the academical side, having the opportunity to involve students during the academical let's say, path is something that will help the student. We know, especially for our statistic, that an engineer will have high chance to find a job. But especially in the southern country like Italy, Spain, Portugal, the unemployment rate is very high. Also, with the people with a engineer background. And in some cases, the main cause is because the student and also the university give not the chance during the study to have an experience that will give to the student the right level of employability in order to be also from a social point of view, because of course it's important also for the person to be able, after an academical career, to find a right job for personal also development. So for sure, the combination and the cooperation in the two, let's say, academical industry is mandatory in order to fulfill this commitment.
Thank you, Roberto. We are soon going to roll further because we have 3 more headings to go through before we are ready today. But Carlos, you are the next on this item.
Yes, well, I wanted to answer from my personal point of view the question that you made 20 minutes ago about what is the meaning of an engineer today. Well, we are talking about the industry, the 4.0 and everything that is evolving very fast. But in my personal opinion, a good engineer should have the scientific learning in the first courses of the career, physics, mathematics especially, and then the different branches, mechanics, electronics, electrics, everything. This, I think, should be distinctive of an industrial engineer. All the basic scientific training before going to the applications, because nowadays with the social networks and everything, everybody knows about everything. But the real scientific training should be in academic and should be taught via the universities. And to distinguish an engineer from other careers, my personal opinion is that mathematics, physics, and all the basic scientific training should be taken care of with a lot of care, because nowadays, because everything is immediate through the social network and everything, and everybody has opinions of everything, at least to have the base, the scientific base is very important. And engineering should be, for a real engineer, should be a must to have this basic training. Afterwards, in the last courses, all the implications related to industry and applications can be done, but first of all is the basic training, scientific training. This is my personal opinion.
Thank you, Carlos, because now we are open for a very interesting discussion that we can also run soon. How to find the right balance between science, engineering, and management-like subjects in the program of industrial engineering and management. How much can we decrease the hours of engineering training and science training to give space for management and similar subjects? Is there a critical border there? How far can we go? Is 1/3 to go too far? 1/3 on each. Is that an unbalanced distribution? Or do we have other ideas about that? Because from my point of view, it's also very important that we as educators of students in our subject area really can say that we are not delivering a student in business administration or in management or in economics. We are delivering to the market engineering students. If we can't stand for that, we have lost everything, I must say. We must keep that in mind. That's my opinion. I should now switch a little to weaknesses. We have now to identify our weaknesses of today. You have identified them. I have also identified them. Let's have a little discussion on our weaknesses in our programs of industrial engineering and management, because they are there. Everybody had witnessed it about it. And what are they? Don't be afraid of giving the situation at home, so to say, because all of us have weaknesses and we have to take them on board and develop them. So now I open the floor, and the first hand is Peter.
Yeah, like I said, the rooting of the industrial internship attitude in the country, in Luxembourg, is pretty tiny. But also the need for industrial research, like I said, the country lives off banking and financial services. They don't want to get dirty. So the attitude toward manufacturing is a little bit less, and digitization is related to bankings and something like that. Those are the two biggest issue, and of course the labor costs, which makes also research expensive. Our PhD students, our postdocs are paid nationally competitive, which is on an international basis pretty expensive. So I think we need to have more output to be worth this additional financing.
Michael?
Yeah, I think that the weaknesses is somehow also referring to what Jan, you just said, that what is the right size of engineering, science, and management topics. I think that there is no answer to that question. The only answer I think we have to provide is that, let me say in a kind of fancy way, we have to provide industrial engineers, okay? But then we have at the same time to provide industrial engineers who are less industrial and more managerial engineers, right? Because those are the requirements from the industry. If we want to create one single European standardized curriculum on industrial engineering, I think we fail, because there are too many topics that are within this large umbrella. What we have to provide on the market is someone who has more focus on engineering and less on management, but at the other side, a little bit more people more with a more managerial and less engineering content. In order to allow the student from one side to choose what they want to do, and in order to create a more segmented and diverse, let me say, product to companies. We have just revised in my university the Master of Science in Industrial Engineering. It's called Management Engineering in my university, okay? And we went from 8 different streams, focused on 8 different topics, to 13, right? Exactly to create a higher segmentation and higher differentiation of the, let me say, of the content. That was the only way to face the market. So I think that the current weakness that I see in some programs is to have only one unique, let me say, profile, and not offering many differentiated profiles.
I have seen a lot of programs in Europe in our field, and I've seen how they have approached the problem to deliver a complete program in industrial engineering and management. And what I observed sometimes is how they have, so to say, misused the possibility to train our students in the right way. Because we must find our niche. We must have a niche of our industrial engineering management candidates. And if they train them together with students in business administration and economics, what is the, so to say, the least mean value in that group? How can you employ your tools? You have trained them in statistics, mathematics, computer science, whatever we talk about. How can you use these tools in a training program where at the same time we have students in business administration and economics? It's impossible, which means that our students will lose a lot if we do that solution, if we train like that.
I must agree with you.
Yeah,
I totally agree with you, but we should not train them or educate with other students. I agree with you.
Correct, Marco, but I see these examples over Europe from time to time, very often, how they mix these kind of students. We had two losers, no winner, and that's a big problem. And I also see a question now from our colleague Wilfried Sinn in Vienna. He says, are we as universities quick enough in changing the curriculums regarding the changing needs of our customers? That means industry. We can relate that to weaknesses. How quick are we to respond on changes? And how much do we preserve of the old days? Because it's easy for the teacher to do the same lectures as 5 years ago, for example. So how agile is the system we work in to accommodate our programs to changes? Is that a big, so to say, weakness in our academic system, or what is it? Comments?
Jan-Erik.
Yes.
Jan-Erik, I have, so the button to raise hand doesn't work. So I'll do that physically.
Yes.
Exactly. No, let me make one point from the company perspective, talking about weaknesses and talking about this question we received. I'm not able to say what the right balance in academia should be, but I don't know if what I'm telling is typical of my country, of Italy, or not. But sometimes when students arrive into companies, sometimes the impression I have is that they fell in love with their theoretical know-how. They fell in love in knowing technology, in knowing things from an academic point of view. And what sometimes I see missing is the pragmatic standpoint to say, should I do this? Should I deepen this kind of technology? And to what extent should I use it? Because I have to find a balance with cost. It has to be to bring an advantage to the company. If I'm a researcher in a company, that's a slightly different topic, but nevertheless, the cost topic is always there. If you work in manufacturing, you can have your fantastic solution from a technical standpoint, which is not pragmatic sometimes. And so who wins in this arena is the engineer that is able to balance both things, to find a solution that is probably not the perfect one from a technical point of view, but finds the balance with a cost perspective. And this is by far a key and winning factor for a student entering the manufacturing or industry in general topic. So this is something that I see sometimes like a weakness. As I said, I'm not able to evaluate that. Is that Latin, Italian, how is in the northern countries? I don't have the knowledge to evaluate that. But this is what we perceive in industry here.
I think it's very good, Antonio, that you articulate that problem, because it's a very important issue to talk about now, how our students will approach reality when they come from university. Have we prepared them for this kind of looking upon the situation, upon the problem, upon the solution? Or are they just concentrating on to find a nice technical solution without thinking about the costs to implement it or to run it? So for students in our program, they must have this knowledge. I mean, they must be aware about there's a balance between cost and other issues. We can't do everything we want, just engineeringly perfect. It must also have a possibility to be implemented in a company that one day must have a profit from what we are doing. So these issues, that could be a very interesting weakness we have, that we are not completely concentrating on the whole chain here, running from idea to the sale of the product. How much cost can we accept on the way to the final product, or what is reliable situation to go through? Fine, thank you for that comment. I see a hand from Louise. Yes, you could give some student perspective.
Yes, I wanted to give some perspective here. Maybe because I'm still in the student environment, I don't have that open horizons in terms of what can be that connection there. I wanted to share one experience that we recently lived in Esteem. So we were approached recently by one company, European company, whose mission is exactly making the onboarding of IEM students to companies. So what does the company provide? So an extra semester or an extra year, just like an extra model of university, okay, for students to enter directly to the companies. So I know that, for instance, there are a lot of companies that have their own methodologies, their own modus operandi, different tools that they use. So it makes sense from that perspective. But we were discussing together, does it make sense for a student to finish as an engineer, after all, of course, finishing their master's degree on industrial engineering and management, and after all, still enrolling a program of 1 year just to make an adaptation to a company? And also, my point of view, of course, once again, pushing again the point of a lot of companies have very specific onboarding processes, methodologies, etc. But also from another perspective, does it require a 2-year program, which is, I guess, the maximum that that company has for the IEM students? Does it require 1 year? I would also like, I don't know if anyone also could join in with this conversation and with this question to try to see. But answering the question from Wilfred that was raised before on the chat, at least from my opinion, I do believe that it's not as fast as should be in terms of adaptation for students to the companies. Because if there's still that need of spending that extra year or that extra formation aside from the IEM degree, it's because, of course, something it's missing there.
That would be a failure, wouldn't it? I mean, if you have spent 5 years being trained to be an industrial engineering management candidate, and then you have to go for another 1 or 2 years to fulfill the requirements from industry, then we must have failed, haven't we? Then we haven't accommodated our program to the requirements that I hope we could fulfill. We could train them in a way that after 5 years, they can go for the first job and be qualified. Then for lifelong learning issues, another thing, because with the changes in industry today and in society, they can't live on what they learned 5, 6 years ago, perhaps, as Peter said, is obsolete. They must be continuously trained in some ways. That's another issue. But if we concentrate on the first 5 years in the 5-year program for a master's degree, we must design it in a way that we can be proud to deliver students who can handle the requirements from industry in the first job, at least, and do it well. Okay, Carlos has the last word in this round, Peter also, and then Carlos, no, it's only
yes.
Peter.
Yes.
Carlos, Carlos, talk.
Okay. No.
Peter then.
Luis says. So, Peter.
I can't see. Peter, your hand is up. Now Carlos comes up also. I think Peter was first. Peter starts.
Well, I'm referring to what Carlos said before. Basically, the university has the scope, the mission to educate students, and Wilfried's question puts it to puts the finger on the weak spot. We need to balance both fundamental education, which I think should be the bachelor, and educate the students to learn, and then in the master to adapt in the last year, like Luis said, or 2 years. Which is the current trend. We cannot educate the cutting, the latest development. We need to educate the students to learn how to learn. And then when they're onboarded at a company, continue learning.
Mm-hmm. Carlos?
Yes, well, I agree with Luis, but I would do it instead of after finishing the 5 years, during the 5 years, to do practices in the companies. As I explained, that is being done in Mondragon University. They have had a great success for many years already. And the practices are fundamental because you cannot be completely separated for the industry for 5 years and then deliver someone that is going to be ready for the industry just not having had any contact before. So the practices for me are fundamental. Maybe from the 3rd year, after the scientific training has been done and the bases are done, or after the 3rd year, to start practices already, because then you will see the importance of the economical part of the solutions that, as I was explained here, that not the best engineering solution sometimes is the most feasible because you have to take care of the cost of it. And you will have also, will be in touch with the different problems inside the company, because the company have people inside. And many times this is the most difficult thing, to deal with people that are working there. So to have a feeling of what the company is, the industry, working in the industries before finishing the studies, for me is very important. And this can be shared with the professors and with the different teachers in the university, and then they will have also the direct feeling of the industry is right now and be evolving. Not everything in academia, 5 years, and then right away into the company, but start before.
We're going to finish the weaknesses. Just a comment from myself. What I have seen on my journeys in Europe, visiting universities with these kind of programs, that is that many universities, they push all these management-like subjects to the last years of the program, and they start the first 2 years with science and engineering. And the students have no contact at all with that kind of work they're going to have later on as graduated from industrial engineering and management. I mean that the first semester they come to university, they should have at least one course module that opens the door for them into our subject area, so they feel comfortable with what they have applied to follow for 5 years. They must meet our subjects, our thinking, our ideas, industrial engineering and management directly the first day they come to university. Then they feel, so to say, planted there, and they can develop successively and all the years through until the last day when they hand in their master's thesis in our subject area. So we leave weaknesses and go to opportunities, because now we can open a lot of doors for opportunities, because there are opportunities for us, but which are the most important opportunities to take on board after what we have heard today, after what we see around us, what's going on in Industry 4.0, what opportunities do we have? Now I'm very interested to hear your points. Who would like to start? I see no hands, but I could miss them also. Who will talk about opportunities? Someone must. Carlos, go on.
Okay, so as I said at the very beginning, the R&D European programs, kind of Horizon 2025 now, and other programs that are partially funded, and where collaboration in between university and different industrial companies are very interesting. These are opportunities because this is a way to insert students, engineering students, into the companies, but being directed by a professor from the university and controlled, and being taught in the different tools, but at the same time doing practical things, innovative things in one industrial company. I think this is a very big opportunity, and I talk about it because of experience. When I was in the industry, we use, especially in ArcelorMittal now, a lot of these programs. And now I am collaborating in different programs, and it's very, very interesting for the collaboration in between university and industry, and university professors with their students inserted in these programs. For me, this is a very big opportunity, and thankfully, European programs are still alive, and they are dedicating a lot of money for this.
I think we have to learn a lot from Southern Europe, because I know in Southern Europe it's a tradition that you let professors or colleagues from industry come into university and work there for a day or for a week or whatever it is, very more often than we ever do in the Nordic countries, for example. It's not a tradition here, like in your countries in the Southern Europe. I think it's very efficient to have a link, a bridge between industry and academia in that way. Marco?
Yes, I think the opportunity here is what COVID has taught us. During the lockdown we were forced to go totally with this virtual digital lecture, right? There were no lectures in presence. Now that COVID will be over, of course, we have reopened the classes, we have reopened the rooms, we are back to the university. But I think that students get used to have digital lectures. We as professors have learned how to use and exploit more and more this way of going digital. The opportunity here is that in this way we can have more, let me say, in an easier way, more lectures coming from outside the university. I have revised my course for this semester, and I was forced during the previous semester to go totally digital, and then for this reason I have invited some colleagues from all over the world to give seminars or industrial seminars, and that was easier for them because they had not to travel, and they had not to travel because this was the only solution. Now, even though they could travel, okay, but they will not travel anymore just to give 1 hour lecture, but the student will not perceive this as a minus. They will perceive this as an opportunity anyhow to have a broader input from all over the world. So I think that even though I can in the near future give my courses totally physical, I will still have 10%, 15% of the course using external professors, using experts from all over the world to give lectures, and I will be in the class, my student will be in the class, but these lectures will be given from outside the class. And I think this is it's something that we need to think about. It's providing value to the students.
Thank you, Marco. At the same time, we heard today people saying in the first part of the conference that we must have less of lectures and more of other issues in the training of students. So there must be a balance again here between this kind of virtual lectures you talk about and other modes of training, of course, if we are going to renew the whole system or not.
Of course.
Yeah. Luis?
Yes, I wanted to agree also with Carlos and Marco in the sense of that it's way valuable also for a student to receive a professional from industry also. I, for instance, can be the vivid evidence. Since last semester, I had one subject that was fully focused also on receiving different professionals to deliver some modules, and I didn't skip one of the lectures. So it was also very interesting to receive it. And since it's something that it's not usually done also as a general practice in all the subjects, also for students, it's way more engaging when we see that it's actually something new that is happening, and to check out and have this gap filled between the uni and the companies. To answer also what has been just said about also new things and opportunities that can come up in terms of practical and practical learning and that students can acquire. I think one very interesting concept that I have heard also recently, talking with a professor from the University of Catania, that they are developing kind of an IEM fab, or also I know that Aveiro constructing right now an IEM lab. So a factory adapted to students for them to exactly study the different parts and process of manufacturing, and also for supply chain or practical uses. So exactly seeing how those theoretical concepts of logistics, supply chain, manufacturing can be applied directly as in a warehouse or in a factory. More than that, just also once again reinforce the idea that it's very important for students to have these subjects co-delivered, also like Professor Peter was saying in the beginning, also with companies, having the introduction of companies and having this possibility of having, for instance, kind of projects being supported by the companies inside of the university. And also, last but not least, I see the fact of having accredited extracurricular activities like the ones that we do, for instance, STEAM, with the credits of the university. So if a student is taking out 1 week to also having an international opportunity of learning outside, that should be also something to be rewarded. Or if it's taking a year of leadership in a student association where it's dealing with internal development strategies, working with the direction of a whole association, international association, should be also something rewardable for a student.
Yes, friends. Antonio, yeah, yes, I see your hand.
Thank you. No, just really appreciate, and also would like to not to repeat what the colleague said, but simply to summarize in the sense of the big opportunity is to insist on discontamination, in my opinion, much stronger than we currently do, really on both sides. So to encourage the fact that students can breathe the atmosphere of a company even before graduating, and even the other way around, as some colleagues said, to have external teachers that give already, when students are learning, their point of view and their perspective about what the company will be looking for. I mean, this is the big opportunity, in my opinion, to be exploited. And so many colleagues said that already, but I want also to put my voice into the table. Thank you.
We're talking about opportunities, and I could just give an example from what I did when I set up a new program in our field at our twin campus Norrköping in Sweden. We talked about industry representatives. How could we train the students in the best possible way for your future demand on them? And they gave us a lot of examples what was important. Mostly, as we had also in our research here in the project, the soft variables, soft skills. But I also said to myself, how can we know that our students in our program, Industrial Engineering and Management, have a focus on the labor market that we are aware about? Do we know everything about what they are heading for? No, we can never know that. And such our program is so special in the way that we train students to be so much afterwards. We must give them a chance that during the 5-year program have a possibility to develop what they find is most important for themselves to learn based on their own, so to say, aspiration of the future. So we opened one semester saying that during this semester, you are free to study whatever you want at academia. If you want to study language, want to study subjects from culture, whatever you want, you can study, and we recognize it, because then they got the chance to develop their own personality for the future job market. And it was very efficient and very interesting what kind of subjects they chosen for this possibility, and train themselves to a future that we were unaware about, but they knew perfectly what they wanted to develop within themselves for the future market. An opportunity we can have for the future now when we open up and redesign our programs a little. I think we must continue because time is running. I have a question here from Henk van Langenheim. He says, medical doctors spend also 7 years, among which a big part practical work is included. Is engineering so much easier? No, it's not, but they have 7 years, we have 5. So if we had 7 years, we could have a lot of practical training, of course, in the 7 years. So friends, the last thing to reflect on is threats. Which are the most evident threats for us as trainers, for you in academia, threats on the future for candidates coming from our program? What do you see today? One threat that is the most dangerous for us and we must take on board. Let's go around and you give your personal view on the threats of the future. I start with Marco.
The threats that I see is the huge competition that we will receive from Southeast from Asia. I think that they are moving very well in terms of education. They are moving very well in terms of course, in business in general. But it's in terms of education, they are preparing very good students, very good graduates, and I think that their universities are becoming very attractive, and also from European students, considering not only the level of education they are providing over there, but the fact that the center of gravity of the world, of the business, is moving in that regions. The risk is that we as a university are going to lose those kind of markets, and we will be less attractive for European students, and we will be attracting for developing countries, which is of course fine, but I think this will relegate us into a kind of a second level, not in the high ranked university. That's what we have to work. The second threat I see is that we can discuss about the quality, but I think that our competitors are not just other universities, but I think that our competitors will become such some big companies like Google, Netflix, or whatever, because it's very easy for us to hire good teachers because they have a lot of money and create programs. Of course, they will not be able to do it in 1 year or 2 years, but the brand that some companies like Google has is very high, and I think that they will become very attractive for faculty members.
Just a comment, Marco. We say in Europe that our university program have to be based on knowledge, skills, and competences. If you compare with your candidates from Southeast Asia, how much of competencies have they been trained on? Okay, we take the next, Antonio. You must unmute. So.
Yeah, sorry. I think not to be underestimated is what the high schools could do, technical high schools. Because it's also likely, and it's already happening, that companies will recruit guys, students coming out of the high schools, because if they think they have to train students anyway, even out of IEM's faculties, they could anticipate times and begin earlier. So taking the students, these younger students, although they do not have an academic curriculum, and to train them directly in what they need. I think it might be kind of threat in this for the IEMs.
Okay, we go to Roberto.
Yeah, one of the threats that I see in the future is higher differentiation in terms of quality, in terms of program between the so-called leading university, like, for example, Politecnico di Milano, di Bari, and the other university. From an HR point of view, of course, when we are looking at an engineer, we are open to consider students from many universities. And the threat in the future will be also that the companies, they are investing only on the, let's say, main university, and they let the smaller one, because they don't have a good name to go down with the quality of program. So we are going to have students also with same, let's say, degree, but very, very different academical background due to this differentiation.
Good.
Thank you.
Luis?
I'll try to also keep it short and concise. So I will go with a broader topic. So crisis management in general, and change management, whenever we talk about, for instance, the digitalization and the not so stable moment that we are living in terms of also for the post-pandemic situation, in terms of going back to classes, going back again to classes, the quality of the education that it's being provided to students in this transitional mode. Also mentioning once again, like I mentioned in the beginning, the different crescendo in terms of areas of and scopes of IEM, and us trying to be as updated as possible with those current trends, and of course those changes of needs in society that are going also to give a bigger importance to soft skills and to the change that we are making in the IEM degree.
Thank you. Carlos?
Yes, I would say that the lack of speed or flexibility from the university side to adapt to the very fast changing world in all domains could be the major threat. So this project we are involved right now, IE3, could be a start point just to avoid this kind of threat. Okay? We have to run very fast because society is changing very fast also, not only in industry. And university has to change the way to adapt and be much faster than has been up to now.
You're right. Peter?
Yeah, I have basically two threats to share. One already Marco mentioned, which is the change of the economic center of the world going to Asia, which goes along with Asian universities being a kind of competition to us, of course. What Luxembourg is doing, we recruit our master students on a pretty international level. So the bachelor students are basically from the greater region, but the master students are really a mixture of international, where we are competing already today with the good universities like Milano, Bari, and also the Asian universities. So that is a threat. The second one is due to the current COVID situation. That impacts the communication between industry and academia. That also makes industrial internships more challenging. And like I said, the economic impact of the industry, not hiring or reducing headcount, right-sizing headcount, is first penalized by students, by interns, which are not hired, and that deteriorates the quality of our education.
Okay, friends, we have gone through the agenda we had today together in this panel, and we have to finalize it by seeing if there are questions from the audience that we haven't answered. And if I go into the chat now, I can see that we have a question from Professor Jim Brown. If you can't see the question, I can read it for you and you can answer it. How do we prepare students for a further, which is unlikely to offer them permanent jobs, but is likely to require them to be very flexible as roles and jobs change? Today we front load education early in life. Should we also design educational programs for continuous and lifelong learning? Our universities need to maybe put more emphasis on adult learners and relearners. That question came early in the discussion, and I open the floor now to hear your reflection on Jim Brown's question. Please, some comments. Roberto?
Yeah, of course, for me, the so-called employability during the time that we are in the company is one of the pillars of the company and of the associates. And I think this concept, so the way that we must continue in learning is also coming also from the experience that we have during the university time. So I think in the program, I like what you, Jan-Erik, said, that we can also, why not offer 6 months of, let's say, another subject that is not a technical. I can say a lot of benefits for contaminating the students to look a little bit beyond, let's say, the engineer education, and also being able in the future to have this lifelong approach will give the opportunity for us in the companies to have always a very well, let's say, trained and open for the change that nowadays in all companies and in the society is happening every day. So this concept of employability, in my opinion, is something that during the interview, I'm interviewing a lot of engineers, we must detect the willingness, and I'm sure that practicing this also during the study could be a positive aspect for all engineers. Thank you.
Thank you, Roberto, for the comments. Are there any other comments on this question we just heard? I see no hands. I think it's time, friends, to wind up a little what we have done together for such a nice 90 minutes, I think it is just now. Thank you very much for your contributions. It was very interesting to discuss with you your opinion on strengths and weaknesses and threats and opportunities for our programs in industrial engineering and management for the future. So what can we say? We don't know, but we must speculate and we must make decisions. for the future, for our students' future career. One word that I heard several times today is flexibility. We must have flexibility in what we are doing. We must be open for changes, and we must have guts, friends, to make changes. Sometimes we wait too long to change because the system inside academia is lazy sometimes to change. It's easy to do the same as you did yesterday. But for the students' future, we as leaders, we must push the change forward and accommodate to what is best for them, best for industry, best for the society we can do. We have a big, interesting opportunity in front of us. So friends, thanks again much for what you did today, what you contributed with. It was a fascinating discussion. We learned a lot. Now we bring it to our heart and we try to implement it. All of you, 58 people who listen to this, bring it to your home institution, discuss it there, and find out how you can contribute to a big change for everybody's benefit. Thank you so much.
Thank you so much, Jan-Erik.
Thank you.
Now it's time for closing. Let me express my gratitude to all colleagues and attendees from all corners of Europe. I personally feel enriched by ideas and also surprising new findings in hearing about the different viewpoints. And I can say that I will try to bring these new ideas also in contributing to write the higher education transformation agenda, as this is one of the main engagement of all Erasmus Plus project coordinators. I can say that starting from the first meeting that has been scheduled on next June the 3rd, I will try to bring these new ideas inside the agenda. I feel committed to keep you all informed about the progress of this agenda. So now it's time for closing the first European Conference on Higher Education, Industrial Engineering and Management. I thank you all for your participation. Thank you.
Thank you very much.
Thank you. Bye-bye.
Thank you. Bye-bye.
Bye.
Alla prossima.
Alla prossima.
Ciao Gianni, andiamo a vincere.
Ciao Roberto, andiamo a vincere.
Ciao, ciao.
Ciao.
Ok.
Alla vista.
Ciao, ciao.
Ciao a tutti.
Ciao.
Ciao.